Hey there, Night Owl. Come on in and get settled, because tonight's story is one I have been sitting on for weeks just waiting for the right moment to bring it to you. If this is your first time here, welcome, pull up a blanket, get cozy, and let's ease into this one together. And if you have been with me before, well, you already know exactly what this means, don't you? Somewhere in Canada, sealed inside solid rock nearly 3 kilometers beneath your feet, there is a pocket of water that has been sitting in total darkness since before the first dinosaur took a breath, since before the first tree grew a root, since before anything on this planet had eyes to open. It is still down there right now in a place almost nobody will ever see, and tonight we are going to find it. But before we climb down into the dark together, do me one small favour first. If stories like this one are the reason you keep coming back, go ahead and hit that like button, tap subscribe, and if you have a moment, leave a comment down below. I would love to know where you're watching from tonight and what time it is on your side of the world. Those little comments make my whole week. Honestly, I read every single one of them. Alright, dim the lights. If you have not already, maybe switch on a fan or something with a soft steady hum and settle in completely, because where we are headed tonight is a very, very quiet place. Let's start on the surface where this whole thing looks perfectly ordinary. Picture a small town in northern Ontario called Timmins. Grey sky pine trees, the kind of place where winter shows up in October and does not really leave until May. Nothing about the surface gives it away. There are homes here, a grocery store, kids waiting for the school bus in the cold. And just outside of town there is a mine shaft that looks from above almost unremarkable. A tower of steel, a cage on a cable, a low hum of machinery. You would drive past it and think nothing of it at all. Every morning ordinary people clock in here. They grab their hard hats, fill their thermoses with coffee clip radios to their belts, and joke around in the changing room the same way people joke before any ordinary shift anywhere in the world. Nobody walks in expecting to touch something that predates continents. They are there for a paycheck and rock and metal they can actually sell by the end of the week. But that shaft goes down and down and down. This is Kidd Creek Mine, the deepest base metal mine on the entire planet, and for more than half a century miners have been riding that cage into the earth, chasing copper, zinc and silver. The ride down takes close to an hour, not a few minutes, an hour. The elevator groans against the cable, the air grows warmer with every passing level, and daylight becomes a memory somewhere around minute 4 or 5. People tend to stop making small talk right about then too. There is something about watching the light disappear above you that turns most conversations into silence, and most silence into something close to reverence. The walls of the shaft blur past in the dim light streaked with moisture, glinting faintly wherever a headlamp catches a thin vein of ore. Somewhere far below, machinery hums steady and low, almost like the heartbeat of the whole operation. It is the kind of sound that settles into your chest a little if you let it. Your ears pop once, then twice. The temperature keeps climbing degree by degree until you find yourself peeling off the jacket you needed on the surface only an hour earlier. Some people describe the ride down as claustrophobic. Others describe it as one of the purest kinds of awe they have ever felt, trapped somewhere between fear and wonder. And honestly, it might be both at once. By the time you reach the bottom, you are almost 3 kilometers underground. For comparison, you could stack 9 Eiffel Towers on top of each other, one on top of the next, and still not quite reach the surface from where you're standing. That is how deep this place goes. The air down there is thick and mineral, the tunnels lit only by headlamps, and the rock pressing in on every side of you is not just old. It is almost unbelievably old. That rock used to be the floor of an ocean, nearly 2.7 billion years ago, long before there was a single flower, a single insect, a single creature with a spine anywhere on Earth. This stone was seafloor, sitting quietly beneath ancient water under a sky that would have looked nothing like ours. Over time, through forces too slow and too enormous for a human mind to properly picture, that ocean floor buckled, folded and hardened into some of the stillest, toughest rock on the planet. The kind of rock that barely shifts, even while entire mountain ranges rise and crumble around it over millions of years. Miners walk through it every single day to reach the copper and zinc they're actually looking for. Most of them have no idea what else is quietly waiting in there with them, something that had been sitting so long it had almost stopped being ordinary water at all, and had quietly become something closer to a message. In the early 2000s, a geochemist named Barbara Sherwood Lawler started spending a great deal of time in those tunnels, and she began noticing something strange. Not something she could see, not at first. Something she could smell. It drifted through the tunnel air, faint but unmistakable, musty and mineral, a little like old coins that had been left out in the rain for too long. Most people would have walked right past it without a second thought. She did not. She followed that smell the way you might follow the scent of something baking in another room of the house, turning her head slightly, walking a little closer, letting her nose do the work her eyes could not. Down one tunnel, along a wall, closer, closer still. She crouched down, tilted her headlamp toward the wall, and there it was. A thin, unremarkable crack running through the solid rock, easy enough to walk past 100 times without ever noticing it. And out of that crack, so slowly you almost had to hold your breath to see it moving at all. Liquid was seeping into the darkness, one quiet drop at a time, the way it likely had been for longer than any living thing could properly measure. This was not the kind of water you picture trickling out of a mountain spring, clear and quick and inviting. This came out slow, thick, almost syrupy, clinging to the stone instead of running freely off it, as if it did not particularly want to leave the place it had called home for longer than anyone could yet imagine. And the moment it touched the open air of the tunnel, it started to change right in front of her, drifting from clear to a soft rusty orange as the iron dissolved deep inside it met oxygen for what may have been the very first time in its entire existence. It was salty too, not ocean salty. Somewhere close to 10 times saltier than the ocean, thick with minerals that had been slowly dissolving into it for longer than most of us can comfortably hold in our heads. And yes, at some point Sherwood Lawler tasted a drop of it, just to understand it a little better, the way any good scientist eventually does something slightly unwise in the name of curiosity. She described it very politely as absolutely terrible. I think we can trust her on that one. It was sulphurous, bitter and thick, closer in texture to something you would find at the bottom of an old jar than anything that ever fell from a rain cloud. Nobody is putting this on a supermarket shelf next to the spring water anytime soon, and if they ever do, please do not be the one who buys it. Here is where the story stops being strange and starts becoming almost impossible to sit with comfortably. When her team finally worked out how long that water had been trapped down there using tools built specifically to measure time on a scale that carbon dating could never touch, the number they landed on was at least 1.5 billion years. In some pockets, discovered even deeper in later years, that number crept close to 2 billion. Let that sit for just a moment. The pyramids of Egypt are considered ancient at roughly 4,500 years old, and they already feel like they belong to a different world entirely. Dinosaurs first walked this earth somewhere around 230 million years ago, and even that feels almost too distant to picture clearly. This water was already old, unimaginably old, long before either of those things existed. When it last had any contact with open sky, that sky would not have looked blue the way ours does, because the atmosphere back then held almost no oxygen at all. the world above that ancient seafloor would not have looked like a place we would recognize as Earth. It might have looked closer to somewhere else entirely. Earth itself is only about 4.5 billion years old, which means this one small pocket of water sitting quietly in that crack had already been down there completely alone for nearly half the entire lifetime of our planet, long before a single human being ever laid eyes on it. And through every single thing that has happened since every ice age, every mass extinction, every mountain range rising and wearing, back down to dust, every shifting continent drifting slowly across the surface of the planet, that particular pocket of water simply stayed exactly where it was, untouched, unbothered, sealed away in absolute darkness, waiting for nothing in particular, because it had no way of knowing that anyone ever was going to come looking for it. There is something quietly moving about that if you let yourself sit with it for a while. Most of us spend our entire lives chasing the next thing, terrified of standing still for too long, convinced that stillness means being left behind. And this water did the exact opposite for 2 billion years. It just held on. Patient beyond anything we could ever manage ourselves in a place with no light and no sound and no company at all, and it ended up becoming one of the most important discoveries in the history of Earth science simply by staying quietly in the dark and waiting to be found. Maybe that is worth remembering the next time your own life feels like it is standing still. Sometimes the waiting is not empty at all. Sometimes it is just quietly becoming something worth finding, which brings us to the question that should be keeping you good company tonight in the best possible way. How exactly do you prove that a liquid is 2 billion years old? You cannot carbon date it. That method only works on things far, far younger than this. There is no label down there in the rock, no fossil trapped conveniently inside it, no ancient calendar carved helpfully into the wall beside it. It is a little like being handed a stranger with no birth certificate, no passport, and no memory of their own, and being asked to name their exact age within a few 100 million years. So how did one scientist standing alone in the dark at the bottom of a Canadian mine end up proving something that still sounds almost too strange to be true? That story, how she actually pulled it off, and more importantly, who she was for the 20 quiet years leading up to that single moment, is exactly where we are headed next. Because this was never an accident. It was one very determined woman, one particular smell she refused to ignore, and 2 decades of her life quietly building toward the moment she finally found that crack in the rock. So get a little more comfortable if you can pull that blanket up a little higher, and let's go meet her. She was not famous back then. Nobody photographed her. Nobody wrote about her. And if you had passed her in an airport in the early 1990s, you would have had no reason to look twice. Just a young geochemist from the University of Toronto, hauling a duffel bag full of sample bottles through a Canadian airport headed toward a mine most people outside the mining industry had never once heard of. Her name was Barbara Sherwood Lawler, and in 1992 she walked into Kidd Creek Mine for the very first time. At that point in her career, geochemistry was still a field figuring out exactly what it wanted to become. Most of the attention in earth science back then went toward the surface, toward rivers, glaciers, and rainfall things you could watch change with your own eyes over the course of a single season. Very few researchers were spending their careers thinking seriously about what might be sitting completely still kilometers down in rock that had not been disturbed since before there were continents shaped anything like the ones on a modern map. It was not considered a particularly glamorous corner of science to specialize in. Sherwood Lawler chose it anyway. She was not looking for anything dramatic that day. She was not expecting headlines or television crews or her name eventually sitting inside science textbooks. She was there to study gas trapped in deep rock, the kind of quiet, unglamorous research that almost never makes the news, the kind most people would never think to ask about at a dinner party. But something about that place pulled at her. She kept coming back. Year after year, she kept finding her way down that same shaft into the same tunnels, chasing something most of her colleagues could not even properly name yet. By this point in her career, she had already spent time in mines scattered across 2 continents, always looking for the same strange thing hiding in the cracks of ancient rock. Most scientists in her field were focused on what sat closer to the surface water, that moved water, that changed with the seasons, water you could actually track and measure with confidence. She was drawn to the opposite, water that did not move, water that seemed to be hiding from time itself, tucked away in fractures so old that nobody had bothered to ask what might still be trapped inside them. Over the years that followed, her work would end up taking her far beyond that one mine in Ontario. She would eventually sample fractures in deep mines on other continents entirely, comparing notes across completely different types of rock, different climates, different mining operations run by people who had never heard of each other, and slowly begin noticing a pattern nobody had fully appreciated before. This was not one strange isolated pocket of ancient water sitting under a Canadian forest. Similar fractures, similar chemistry, similar signs of extremely old trapped liquid kept turning up in deep rock all over the world, on completely different continents in rock that had formed under completely different conditions. She was not just studying one curious anomaly. She was slowly mapping out the edges of something far bigger, an entire hidden layer of the planet's water cycle that almost nobody had thought to go looking for. Can I be honest with you for a second? I think there is something a little bit stubborn about people like this. The ones who spend decades chasing something almost nobody else believes is worth chasing. Most of us are taught to look for quick results, fast answers, proof within a reasonable amount of time. She spent years collecting samples that for a long while told her almost nothing conclusive at all. And she kept going back anyway. 17 years passed between that first visit in 1992 and the moment everything finally changed. By 2009, Sherwood Lawler had built an entire career around this pursuit, and Kidd Creek had grown deeper, still miners pushing further down into the earth, in search of copper, zinc and silver. She and her team descended once again, this time reaching a section of tunnel roughly 2.5 kilometers beneath the surface, deeper than almost anyone in her field had ever managed to sample before. The equipment for a trip like that is not simple. Sample bottles have to be sealed in a way that keeps outside air from contaminating anything the moment the liquid is collected, because even a tiny amount of contact with modern air can throw off a reading entirely. Everything has to be prepared with a kind of care most of us reserve for something fragile and irreplaceable, because in a sense that is exactly what it is. You do not get a second chance at collecting a sample like this cleanly. If it goes wrong, the water is either gone or ruined or simply impossible to trust. And there in a crack running through some of the oldest rock on the continent, they found water seeping through slow and heavy, exactly the kind of trace she had been hunting for nearly 2 decades. They collected it, carefully sealed it, and prepared to send it across an ocean for testing. Now here is where the story gets a little bit tense in the best possible way. Dating water. This old is not something you can do with a simple test in a university lab down the hall. It requires extremely precise equipment, the kind that can measure gases dissolved so faintly inside a liquid that most instruments would never even notice they were there. So the sample was packaged up and shipped to a colleague at Oxford University in England, a researcher whose laboratory had exactly the kind of sensitive machinery this project required. And then she waited. Days passed. Then weeks. The kind of results that should have come back fairly quickly simply did not arrive. If you have ever sent something important off into someone else's hands, and then had to sit there quietly hoping it does not get lost or broken or forgotten, you already know exactly what the waiting feels like. Eventually unable to sit with the silence any longer, she picked up the phone and called the lab directly. What came back on the other end of that call was not the answer she expected. The researcher in charge of the testing sounded almost apologetic. He told her something had clearly gone wrong on his end. The readings coming off his equipment were suggesting an age for the water that simply could not be correct, something in the range of 1.5 billion years old, maybe more. He assumed his machine had malfunctioned. Nothing that old moving that freely had ever been recorded in liquid form before. As far as he was concerned, the only reasonable explanation was equipment failure. Sherwood Lawler listened to all of this calmly. She asked him a simple question. Had he checked the machine itself, run a calibration test, made absolutely sure nothing mechanical had gone wrong? He had. Everything checked out fine. The equipment was working exactly as it should. It was the number itself that felt impossible. And then instead of agreeing with him, she asked him to run it again. I love this particular part of the story because it says so much about the kind of person she turned out to be. None of this happened in comfortable conditions either. Fieldwork like hers means weeks away from home-riding elevators, down into mines that smell like diesel, and wet stone wearing the same heavy gear day after day, coordinating with mining companies who are understandably far more interested in copper and zinc than they are in water samples for a university research project. It means long stretches of uncertainty, results that take years instead of days, and constantly having to explain to funding committees why this particular kind of research is worth paying for at all. There is no glamour in most of that. There rarely is in the kind of science that ends up changing how we understand the planet. Most of us faced with an expert telling us our results were probably a mistake would quietly assume they were right and move on. She had spent 17 years building toward this exact moment. She trusted the process more than she trusted the panic in someone else's voice on the other end of a phone line. The machine was not broken. Test after test, the numbers kept landing in roughly the same place. This was not a fluke, and it was not equipment malfunction. It was real. Water sitting quietly in fractures of rock beneath a Canadian forest had been trapped there for somewhere in the neighbourhood of 1.5 billion years, untouched by the surface world the entire time. Can you imagine being the person who has to walk into a room full of respected scientists and calmly explain that number out loud for the very first time? Because that is exactly the position she found herself in. And to her credit, the scientific community, cautious, as always, did not simply take her word for it. They asked for more evidence. They asked her to explain her methods in detail, to defend every step of the process, to rule out every possible alternative explanation, before they would accept something this extraordinary. Some of that pushback, in fairness, probably had a little to do with who was delivering the news in the first place. Geochemistry and mining research were not exactly fields overflowing with women in leadership positions back then, and a certain kind of skepticism tends to land a little heavier, depending on who is standing at the podium. She has never made a great deal of noise about that part of her story. She simply kept publishing, kept defending her data point by point, and let the evidence do the talking until the doubt quietly ran out of places to hide. That is actually how good science is supposed to work if you think about it. Not blind trust and not blind doubt either, but that uncomfortable middle place where you have to prove something so thoroughly that even your harshest critics eventually run out of objections. She did exactly that. And a few years later, her team pushed even deeper into the same mine and found water that appeared to be even older, still edging closer to 2 billion years, in a discovery that would eventually make headlines around the world and quietly reshape an entire branch of Earth science most people had never heard of before that point. In the years that followed, she went from being a researcher. Few people outside her own field could name to one of the most widely recognized geoscientists of her generation, invited to speak at gatherings of scientists from every corner of the globe, her work cited by researchers studying everything from ancient microbial life to the possibility of water hiding beneath the surface of other planets entirely. Not bad for someone who spent nearly 2 decades being politely asked by other scientists why she kept going back to the same mine looking for water nobody believed could possibly be there. Here is something I keep thinking about with this story, and maybe you will too once you sit with it for a moment. We tend to imagine big discoveries happening in a flash, a single lightning bolt moment of genius. But this was not lightning. This was one woman showing up to the same unglamorous mine year after year for almost 2 decades, long before anyone else thought it was worth the trouble. Have you ever kept quietly showing up for something long after everyone around you had stopped believing it would ever pay off? That is a strange kind of patience to hold on to. And in her case, it eventually cracked open one of the biggest hydrological discoveries of the last century, because what she had actually found was not just old water. It was proof of something scientists had only ever guessed at before, a hidden layer of the planet's water cycle, sitting far beneath everything we normally think of as groundwater, sealed away in rock nobody thought could hold onto liquid for anywhere near that long. For as long as people had studied water on this planet, the assumption had always been fairly simple. Water moves. It falls as rain, it runs into rivers, it soaks into soil. It eventually finds its way back to the ocean over and over in a cycle most of us learned about, with a simple diagram in a school classroom. Her work quietly broke that assumption apart. Some water, it turned out, simply stops moving altogether and waits for longer than the diagram had ever accounted for. But knowing that the water was old was really only the beginning of the puzzle. The harder question, the one that would go on to occupy years of her career, was figuring out exactly how liquid trapped in solid rock could sit still for that long, without leaking away, without mixing with anything newer, without a single drop escaping for over 1 billion years. Rock's not supposed to hold on to anything that perfectly. Pipes leak, basements flood. Even the sturdiest containers we build ourselves tend to fail eventually. And yet somehow this stone had managed to keep its secret sealed shut for longer than most of us could ever picture, without a single crack ever letting it slip away. To understand that part of the story, we actually need to go a little further down into the mine itself, into the strange still world she and her colleagues had to learn to work inside, past the elevators and the headlamps and the endless dripping quiet of those tunnels, into the kind of rock that does not behave the way rock is supposed to behave at all. A place built entirely around chasing metal that quietly turned out to be hiding something far older and far stranger than anyone digging there ever expected to find. Long before anyone ever said the words 2 billion years old out loud inside the St. Kidd Creek, had already made headlines once before for a reason that had nothing to do with water at all. It happened in the fall of 1963, decades before Barbara Sherwood Lawler ever packed a duffel bag for Timmins. An exploration geologist named Ken Dark was working for a company called Texas Gulf Sulphur, hunting for ore across the forests of northern Ontario. His employer had spent years and a small fortune drilling one disappointing hole after another, chasing a hunch that the region was hiding something valuable underground. By the fall of that year, they had sunk roughly $3 million into the search and had almost nothing to show for it. In the mining business, that is the kind of number that tends to end careers, not launch them. On the 7th of November, Dark's crew set a diamond drill turning into the ground on a quiet stretch of property that had until recently belonged to the estate of a local landowner. It was cold, unremarkable bush country, the kind of place that had already swallowed years of the company's money without giving anything back. 4 days later, the drill bit cut into something that made every person on that site go very, very quiet. A massive dense vein of sulfide ore thick with copper, zinc and silver, running far deeper than anyone had expected to find it. Dark was experienced enough to understand immediately what he was looking at. That same night he brought the core samples straight to his motel room, instead of leaving them at the site until morning, unwilling to let something this valuable sit unattended even for a few hours. This was not a promising sign. This was one of the richest ore discoveries anyone on that crew would ever see in their entire career. And here is where the story takes a turn that has nothing to do with geology and everything to do with human nature. Dark and his supervisor did not celebrate loudly or call the newspapers or throw a party back at the office. They did something almost the opposite. They quietly moved the drill rig away from the exact spot where the discovery had been made and repositioned it somewhere nearby to confuse anyone who might come looking. Then, according to accounts from people who were there, they cut down saplings and planted them in the disturbed ground, where the original hole had been trying to make the site look untouched. They even paid the drilling crew a little extra quietly to keep the whole thing to themselves for as long as possible. Rather than sending the core samples to a nearby laboratory for testing, where word might leak out, they flew them all the way to a lab in Salt Lake City instead, just to keep the results contained. Can you imagine sitting on a secret that big in a town small enough that everybody already knew everybody else's business? For months this company said almost nothing publicly, while quietly buying up more than 60,000 acres of surrounding land under the cover of ordinary paperwork, and while several of its own employees, including people close to the discovery, began quietly purchasing shares of the company's stock for themselves. Rumours, of course, are almost impossible to fully contain, especially in a small mining town, where everybody knows everybody else's business. By February of the following year, a newspaper had already printed a front-page story hinting that something big was happening out near Timmins. Whispers turned into speculation, and speculation turned into a full-blown financial frenzy. One unrelated company sitting on a completely different and far less promising piece of land nearby saw its stock price rocket upward in just a matter of days, purely because rumours connected it wrongly to the real discovery. Ordinary people, secretaries and shopkeepers and small investors who'd never bought a mining stock in their lives watched that price climb and rushed in terrified of missing out. It eventually collapsed almost as fast as it had risen, wiping out a great many of those same people, and the whole affair became the centre of a fraud scandal that Canadian financial history still talks about, a cautionary tale still taught in business schools today, about what happens when rumour outruns fact and when excitement gets mistaken for evidence. On the 16th of April, 1964, Texas Gulf Sulphur finally held a press conference and confirmed what half of northern Ontario had already suspected. The company had made one of the largest base metal discoveries in North American history. The very next day, trading volume on the Toronto Stock Exchange reportedly outpaced even the chaos of the notorious crash of 1929 in New York. Prospectors and speculators swarmed the region so quickly, using helicopters to stake claims faster than anyone could keep track of that. The whole event earned itself a nickname in the newspapers at the time. People called it the Whirlybird Rush. That mine has never really stopped since. Ownership changed hands more than once over the following decades, passing from an American company to a Canadian government corporation to a series of larger international mining firms, until it eventually landed in the hands of the same global company that still runs it today. Through every single one of those changes, through every rise and fall in metal prices, through 6 full decades of shift changes and cage rides and blasted rock, that same shaft kept going deeper. The very cage that carried Sherwood Lawler down into the dark decades later was riding rails first laid down by men chasing nothing more romantic than copper. I have to be honest with you, there is something almost funny about this part of the story in a slightly uncomfortable way. All of that secrecy, all of that scheming, all of that frantic land grabbing over copper and zinc, metal that gets melted down, shaped into wire and pipe and eventually forgotten in the walls of ordinary buildings. Meanwhile, sitting quietly in the rock beneath all of that noise and greed was something infinitely more valuable than anything on the stock exchange that week, and not one single person chasing a fortune in 1964 had the faintest idea it was even down there. Sometimes the most remarkable thing in the room is not the thing everyone is fighting over. It makes you wonder how many other ordinary places are quietly sitting on something extraordinary that nobody has bothered to notice, yet simply because the obvious prize in front of everyone's eyes was loud enough to keep their attention elsewhere. Which actually brings us to a question worth sitting with for a moment. Why this rock? Of all the mines in the world, why did this particular stretch of stone manage to hold on to liquid water for close to 2 billion years, without leaking, without mixing with anything newer, without giving up its secret a moment before Sherwood Loller's team came looking for it? The answer has everything to do with where exactly this rock came from. The stone that makes up Kidd Creek belongs to something geologists call the Abitibi Greenstone Belt, a slice of ancient volcanic seafloor embedded within an even larger, far older piece of the continent known as the Canadian Shield. This rock formed close to 2.7 billion years ago during a period of Earth's history called the Archean, when volcanic activity along an ancient ocean floor slowly built up layers of lava and mineral-rich sediment that would eventually harden into exactly the kind of dense crystalline stone mining companies dream about. Here is the part that matters most for our story, though. Rock like this is nothing like the soft porous sandstone you might picture water soaking through a sponge. This is tightly crystalline, almost glass-like in its density, riddled only with thin isolated fractures instead of the open connected pore spaces you would find in looser sedimentary rock. And crucially, the Canadian Shield happens to be one of the most tectonically stable, least disturbed pieces of continental crust anywhere on the entire planet. While other regions of the world have spent the last 2 billion years being folded, cracked open, melted and rebuilt by shifting continents and volcanic activity, this particular slab of ancient seafloor has mostly just sat there quietly undisturbed for an almost unbelievable stretch of geological time. Over that same period, the fractures that did exist slowly sealed themselves shut mineral by mineral. Groundwater, moving through tiny cracks in rock like this, tends to leave behind traces of quartz and other minerals as it moves, and over enormous stretches of time, those traces build up along the walls of a crack, the way limescale builds up inside an old kettle, until eventually the crack seals itself closed from the inside. Whatever water happened to be sitting inside that particular pocket at the moment it sealed simply had nowhere left to go. It was not being actively hidden by anything. It was just quietly forgotten by rock that had stopped moving long before humans existed to notice. Think of it a little like the difference between a house that gets renovated every decade, walls torn down, pipes, replaced water finding new paths through every fresh crack, compared to a house that has been sealed shut and left completely untouched since the day it was built. One of those houses cannot keep a secret for very long. The other one absolutely can. Kidd Creek's rock is very much the second kind of house, and the ancient water inside it simply had nowhere left to go, and nothing left to disturb it for 2 billion quiet years in a row. And if you think that sounds impressive, Canada apparently was not finished showing off. A little further north in the Northwest Territories, along the shores of a remote river, most people will never see in person, sits a formation of rock called the Acasta Gneiss, discovered by a geologist doing fieldwork back in 1983. It holds the current record for the oldest confirmed rock on the entire surface of our planet, dated to just over 4 billion years old. Considering that Earth itself is thought to be roughly 4.5 billion years old, that means this particular stone has been sitting there since almost the very beginning of the planet's existence, old enough to have formed while Earth was still cooling down from its own violent birth. Researchers who have gone looking for it describe the outcrop itself as almost disappointingly plain to look at, grey-weathered, easy to walk right past without a second glance, scattered across an area smaller than most public parks. Some geologists have joked that you could stand with 1 foot on rock that is 3.5 billion years old, and the other foot on rock that is a full 4 billion years old, and never once be able to tell the difference just by looking at it. They have even resorted to using magnets in the field, since the very oldest sections of that particular rock happen to carry a faint magnetic signature that newer material nearby does not share, which is a strange thing to picture if you ask me. Scientist wandering a frozen riverbank near the Arctic Circle, waving a magnet over grey stone trying to locate a piece of the planet's own baby pictures. Isn't it strange when you stop to think about it that so much of Earth's oldest, quietest history seems to be tucked away underneath one enormous, unassuming stretch of Canadian forest, somewhere between 2-billion-year-old water and 4-billion-year-old stone? This one patch of the continent seems to be doing an awful lot of the planet's memory keeping. There is something almost comforting about that idea, honestly. In a world that is constantly changing, constantly being paved over and rebuilt and forgotten, there are still a few corners of the planet stable enough, patient enough, to hold on to something exactly as it was for longer than human beings can properly comprehend. Maybe there is a small lesson buried in that about the kind of foundations that actually last. The steady, unglamorous ones sitting quietly out of sight tend to outlast almost everything built loudly on top of them. The helicopters and the stock tickers and the fortunes made in 1964 are long gone now. Footnotes in old newspapers nobody reads anymore. The water is still down there. What would you guess is hiding under the ground closest to you right now? It is a strange question to sit with, isn't it? Once you know a story like this one. Most of us walk around all day without a single thought for what might be sitting still beneath our feet, patiently for longer than we could ever imagine. So now we understand why the rock could keep its secret for so long. What we still have not answered is the harder, stranger question. If nobody was standing there with a stopwatch 2 billion years ago, how does anyone actually calculate a number that specific? No calendar, no fossil, no witness of any kind. Just a scientist, a sample bottle, and some of the strangest, most sensitive chemistry on Earth, waiting to explain exactly how you read a clock that has no hands, no numbers, and no face at all. That part of the story is where things get properly clever, and it is exactly where we are headed next. Here is a fair question to sit with before we go any further. If somebody handed you a glass of water right now and told you it was 2 billion years old, how exactly would you even begin to check if that were true? Most of us, if we are being fair, would probably reach for the one method we already half remember from a school science class. Carbon dating. It sounds official, it sounds scientific, and it gets mentioned constantly whenever anything old comes up in conversation, from mummies to fossils to old wooden furniture. So let's clear something up right away because it matters for the rest of this story. Carbon dating would have been completely useless here. Not slightly limited, completely, entirely useless. Carbon dating works by measuring a radioactive form of carbon that slowly disappears at a steady, predictable rate over time, roughly cutting in half every 5,700 years or so. That sounds like a long time until you realize that after about 50,000 years there is simply nothing meaningful left to measure. The signal fades out entirely the way a photocopy of a photocopy eventually turns into an unreadable grey smudge. Trying to carbon date something 1.5 billion years old would be a little like trying to time an entire marathon using a stopwatch that automatically shuts off after the first 10 seconds. Technically, a clock just not remotely the right one for the job. Quick question for you while we are on the subject. Before tonight, did you assume carbon dating could measure literally anything? Old, dinosaur bones, ancient, rock, distant stars, all of it. A lot of people do. It is one of those scientific terms that gets used so casually in movies and documentaries that most of us never stop to ask what it can and cannot actually do. Now, you know one of its limits, and that alone puts you ahead of most casual conversations about ancient artifacts at any dinner party you will ever attend. So what do you use instead when the number you're chasing is not measured in thousands of years but in billions? The answer takes us into one of the strangest, quietest corners of chemistry, a small family of elements that most people forget even exist. Helium, neon, argon, krypton, xenon. Scientists call them the noble gases, and if chemistry classrooms handed out personality types the way certain online quizzes do, these 5 would absolutely be labelled the introverts of the periodic table. They do not bond with other elements. They do not react. They do not combine. They do not get involved in anything happening around them. Put them in a room with practically any other substance on Earth, and they will simply float there completely unbothered, refusing to participate in whatever chemical drama is unfolding nearby. You've actually met most of these elements before, even if nobody ever introduced you properly. Helium is the squeaky voice trapped inside a birthday balloon. Neon is the warm glow behind an old diner sign late at night. Argon quietly fills the space inside most ordinary light bulbs, keeping the glowing filament from burning out too quickly. Xenon lights up the headlights on certain cars with that bright, slightly bluish beam you sometimes notice in your rearview mirror on the highway. Every single one of these elements so useful, so present in ordinary daily life, and every single one of them almost pathologically unwilling to chemically interact with anything around it. That personality quirk, oddly enough, is exactly why they turned out to be the perfect witnesses for a 2-billion-year-old crime scene. That standoffish personality, as it turns out, is exactly what makes them so useful for reading time. Deep inside rock, like the kind sitting at Kidd Creek, there are naturally occurring traces of uranium, thorium, and potassium radioactive elements that decay extremely slowly, releasing tiny amounts of these noble gases as a byproduct along the way. This happens everywhere, constantly in rock all over the world. But here is the part that makes ancient sealed fracture water so special. Because those noble gases refuse to react with anything else around them, they cannot get absorbed, consumed, or chemically transformed once they are released. They simply drift into whatever water happens to be sitting nearby, and then because that water has nowhere left to go, either sealed tightly inside solid rock, those gases just keep quietly building up, year after year, century after century, for as long as the water stays trapped. Picture a rain gauge sitting in someone's backyard, the kind with a clear glass tube that slowly fills up during a storm. Nobody needs to stand outside watching it the entire time to know how much rain fell overnight. You just check the tube in the morning and read the level. Radiogenic noble gases work on the exact same basic principle, except instead of measuring rainfall over the course of a single evening, this particular gauge has been quietly filling one nearly invisible molecule at a time for well over 1 billion years sealed inside a container. Nobody even knew existed until somebody finally thought to check it. Sherwood Lawler herself has described it rather beautifully, I think, as something close to watching passengers slowly board a train. Nobody gets off. Nobody leaves early. The gas simply accumulates one small addition after another with absolutely nowhere else to go, which means if you know roughly how much uranium, thorium and potassium sits inside a particular type of rock, and you know the extremely well-established, extremely reliable rate at which those elements decay, you can measure exactly how much of each noble gas is built up inside a trapped pocket of water, and calculate with real precision how long that water has been sitting there collecting them. The reason these particular elements work so well for a story spanning billions of years rather than mere thousands comes down to how slowly they actually decay. Uranium takes something in the neighbourhood of 4.5 billion years for half of any given sample to break down. Thorium takes even longer, well over 10 billion years. Potassium sits somewhere in between at roughly 1.25 billion years. Compare that to carbon ticking away in a matter of thousands of years, and you start to understand why one clock works beautifully for a wooden artifact from an old shipwreck, while a completely different clock is required for something old enough to have witnessed the rise and fall of entire mountain ranges. It works a little like judging how long a candle has been burning purely by measuring how much wax has pooled and hardened beneath it. Nobody needs to have watched the candle burn from the very first moment it was lit. The evidence left behind tells the story completely on its own. Here is where I have to give real credit to how careful this particular team was, because measuring one noble gas and calling it a day would have been the easy way out. They did not do that. Sherwood Lawler and her colleagues measured 4 separate, completely independent noble gas signals inside the very same water sample, each one accumulating from a slightly different radioactive parent element, each one ticking along at its own separate rate. And then they compared all 4 results against each other. Think about how detectives on any decent crime show handle a case that actually matters. They never rely on a single witness statement alone, because one account, however convincing, can always be mistaken biased or simply wrong. They want multiple independent witnesses standing in different corners of the room who never spoke to each other beforehand, all describing the same sequence of events. When those separate accounts line up perfectly without any coordination between them, that is when a case becomes airtight. That is essentially what happened here, except the witnesses were not people. They were 4 different radioactive elements quietly ticking away inside the exact same drop of ancient water, each one completely unaware the others existed. If those 4 independent clocks had disagreed with one another even slightly, the whole discovery would have collapsed under its own weight, and rightly so. A single strange number can always be written off as contamination, or a lab error, or some overlooked variable nobody accounted for. 4 separate unrelated clocks built from completely different radioactive elements, all converging on roughly the same staggering figure, is a very different kind of evidence altogether. That is not a coincidence anymore. That is confirmation. There is a detail here that I find quietly satisfying, and it is worth pausing on for a moment, because it is such a wonderfully unglamorous, patient way to prove something extraordinary. There was no single dramatic reveal, no flashing light, no dial that suddenly spun to the correct number. Just 4 quiet, independent lines of evidence checked and rechecked against one another until there was simply no reasonable doubt left standing. And even that was not the end of the checking process. The team also examined the specific chemical fingerprint of the water itself, comparing its ratios of oxygen and hydrogen isotopes against what almost all rainfall and river water on the surface of our planet naturally carries today. Every drop of modern precipitation on Earth shares a fairly consistent chemical signature, shaped by the way water evaporates, travels through clouds, and eventually falls back down as rain, no matter where on the planet that rain happens to land. Think of it almost like a regional accent. Water that fell as rain last month in Ontario and water that fell as rain last month in Arizona still share the same broad family resemblance, the same underlying grammar, even if the details differ slightly. This ancient fracture water did not share that family resemblance at all, not even close. It sat completely outside the normal range, further confirming that whatever this liquid was, it had not casually mixed with the modern water cycle at any point in recent memory. It belonged quite plainly to another era, entirely speaking a chemical dialect nobody currently walking around on the surface of this planet has ever heard spoken. I think a lot of people hearing a story like this for the first time quietly assume that ancient water must somehow look or feel different from the water we already know, glowing faintly or shimmering, or doing something visibly strange in a beaker. It does not. Chemically speaking, the difference is not something you could ever spot with your own two eyes. The difference lives entirely in these invisible traces of gas quietly counting time, inside a substance that otherwise looks like nothing more than salty orange-tinted liquid seeping out of a crack. Maybe that is the real lesson tucked inside this whole part of the story if you're willing to sit with it for a second. The most extraordinary things are rarely the ones announcing themselves loudly. Usually they're just sitting there patiently waiting for somebody curious enough and careful enough to actually go looking. We do this to people too, if you think about it. We assume the interesting ones are the loud ones, the ones performing, the ones demanding attention in the room. More often than not, the most remarkable story belongs to somebody quiet, sitting off to the side who nobody bothered asking a single question. Have you ever thought about the fact that solid rock is quietly keeping time all around us right now, whether or not a single person is paying attention to it? There is something almost humbling about that. While we go about our ordinary lives worrying about traffic and deadlines and what to make for dinner stone beneath our feet is patiently ticking away on a clock running in billions of years, instead of minutes completely indifferent to whether we ever bother to read it. Once Sherwood Lawler's team had finally nailed down the water's true age using every one of those independent methods stacked carefully on top of each other, they assumed the strangest part of the discovery was already behind them. A number that big confirmed that thoroughly felt like it should have been the entire headline all on its own. They were wrong, because tucked inside that same ancient sealed-away water in Kidd Creek, and in similar fracture networks discovered later on other continents entirely, researchers eventually found something that had absolutely no business surviving down there at all. Not a fossil. Not a trace of something that used to be alive the way you might find in old rock. Something alive right now in the present tense. Something that had apparently been quietly living, feeding and surviving in complete darkness, cut off from sunlight, cut off from the surface entirely, for longer than most living things on Earth have any right to exist. Everything you have ever learned about how living things get their energy, plants, animals, every creature you have ever seen documented on a nature program, all of it ultimately traces back to sunlight in one way or another. So what happens to that entire rulebook when something manages to survive for a very long time in a place the sun has never once reached? Figuring out how something could possibly be alive down there without a single ray of sunlight ever touching it turns out to be an even stranger story than the water itself. As it turns out, Sherwood Lawler's own team had already stumbled onto part of this mystery years earlier, sitting right there inside that same Canadian water, without fully realizing what they were looking at. Back in 2008, researchers studying that ancient fracture water at Kidd Creek noticed something drifting quietly through it. Not many. Roughly 5,000 cells in every milliliter, which is a small enough number that you would need extraordinarily sensitive equipment to even notice them at all. Somewhere around 50 times fewer than what you would typically find in an ordinary glass of surface water. But they were there, living, feeding on the sulfate dissolved in that ancient brine, converting it quietly into sulfide, the way certain bacteria have learned to do in low oxygen environments all over the world. Think about that for a moment. Something had been alive quietly inside water that had not touched daylight since before there were dinosaurs, before there were forests, before there was anything resembling the world you and I would recognize. Not a fossil left behind by something that used to live there once a very long time ago. Something still going, still functioning, still in its own extremely patient way alive right now. At the time, it read almost like a footnote to the bigger headline about the water's age. A curious detail worth a mention then set aside. Nobody yet understood just how strange this particular kind of life really was, or how far the story would eventually stretch all the way to the opposite side of the planet. Because if you really want to understand what it means to survive somewhere, the sun has never once reached you have to travel to South Africa into a gold mine so deep that the walk from the surface to the working face takes longer than most people's morning commute. The mine is called Mponeng, and we're going to spend proper time there together shortly, because its story deserves its own full telling. For now, all you need to know is this. Somewhere close to 3 kilometers beneath the surface, in water squeezed out of rock that has sat undisturbed for an extraordinary length of time, in a part of the world about as far from that quiet Canadian forest as you could possibly travel, a team of researchers in 2008 decided to sequence every scrap of genetic material they could find in a single sample. The technique they used is called metagenomics, a fairly young branch of biology at the time, which allows scientists to read every fragment of genetic code present in an environmental sample all at once, rather than trying to grow and isolate one organism at a time in a laboratory dish. It is a little like being handed every torn page from every book in an entire library, all shuffled together in one enormous pile, and being asked to work out exactly how many different books were originally sitting on those shelves based purely on reconstructing the fragments. For almost every sample ever studied this way, the answer comes back as dozens, sometimes hundreds of different books all mixed together. This is fairly routine work in modern microbiology. You take a sample from soil, or a lake, or the human gut, and you expect to find dozens, sometimes hundreds of different species tangled together, each one playing some small role in a much larger community. That is simply how life on this planet almost always organizes itself. Nothing survives entirely alone. Everything depends on something else. Except this time it did not. Whoever first looked at that data must have assumed at least for a moment that something had gone wrong with the equipment. Real ecosystems simply do not look like this. When the results came back, the scientists found exactly one type of organism in that water, not the dominant one sitting slightly ahead of a few smaller competitors the way you might expect. One, full stop, making up more than 99% of everything detectable in that sample, with barely a trace of anything else keeping it company. They gave it a name shortly afterward, Desulforudis audaxviata, and the scientific community quietly began referring to it as something that had never technically been documented before on this planet. A single species ecosystem, one organism alone running its own entire world. Can you sit with that for a second? Every other ecosystem you've ever heard of, a coral reef, a rainforest, the patch of soil underneath your own back garden, depends on an enormous tangled web of different creatures leaning on each other for survival. This one did not need anybody. It had built a life entirely by itself in a place that should have made life completely impossible in the first place. So how exactly does something manage that? The answer comes down to where its energy is actually coming from, and it has absolutely nothing to do with the sun. The rock surrounding that water contains natural traces of uranium and thorium, the very same radioactive elements we talked about a little earlier, quietly decaying at their own steady pace. As they decay, they release radiation strong enough to physically tear apart nearby water molecules, splitting them into their basic components through a process scientists call radiolysis. One of the byproducts of that splitting is hydrogen gas. Think of it a little like a light bulb that never gets switched off, except this particular bulb has been burning quietly inside solid rock for millions of years, powered not by electricity, but by the natural ongoing decay of radioactive minerals nobody ever installed on purpose. Most living things treat radiation as something to avoid entirely a hazard, a threat. The reason you wear protective equipment around certain kinds of equipment. This particular organism apparently looked at that same hazard and quietly decided to build an entire way of life around it instead. And hydrogen gas, it turns out, is exactly what this particular organism needed all along. Desulforudus audaxviata survives by combining that radiolytically produced hydrogen with sulfate dissolved in the surrounding groundwater, converting it into sulfide and releasing usable energy in the process. The same basic sulfate reduction trick we saw hints of back at Kidd Creek, just taken to a far more extreme and self-contained conclusion. In plain terms, this organism figured out how to eat the byproducts of a slow natural nuclear reaction happening inside the rock around it, while every plant, every animal, every creature you can picture living on the surface of this planet ultimately runs on energy borrowed from sunlight. This one small bacterium found a completely different power source, sitting quietly in the dark, fueled by the same radioactive decay most of us associate with danger rather than dinner. I find something almost poetic about that, if you allow me a moment of personal opinion here. Life on the surface spends its entire existence chasing light growing toward it, timing entire seasons around it, built from the ground up around the presence of the sun. And then completely independently, in total isolation, something figured out how to build a whole different rule book from scratch, using the one energy source most of us were taught to be afraid of. There is more too. When researchers studied the genome of this organism closely, they found something almost unsettling in how complete it was. Genes for pulling nitrogen directly out of its surroundings, genes for building every single amino acid it would ever need from raw materials, genes for fixing carbon into usable building blocks, and even genes allowing it to form a hardened dormant spore if conditions ever turned against it. Every tool required for a fully independent existence, all packed into one small uncomplicated organism, because in a world with no other species to lean on, self-sufficiency was never optional. It was the only option available. Compare that to almost any creature living on the surface of this planet, including us. Human beings cannot manufacture our own vitamins from scratch. We rely on plants, on animals, on entire farming systems, on other people, for practically everything that keeps us alive. Even the simplest houseplant depends on soil bacteria it never personally negotiated with. This organism needed absolutely none of that. It arrived essentially fully equipped for a life with no support system whatsoever, the biological equivalent of being dropped into the wilderness with a bag already containing every single tool you could possibly ever need. Here is a question worth turning over in your mind for a moment. What would it actually take for you to survive completely alone with absolutely no outside help, indefinitely? Most of us cannot go a single week without depending on other people, in ways we rarely even notice: the person who grew our food, the person who built our home, the person who taught us the skills we lean on every single day. This particular organism never had that luxury, and somehow it did not just survive. It thrived quietly for what researchers now believe may stretch back millions of years. There is something worth sitting with in that beyond the biology of it. Most of us go through at least one stretch of life where we feel completely cut off from other people, from support, from anything resembling the community everyone else seems to take for granted. It rarely feels like strength while it is happening. It usually just feels like being alone in the dark waiting for something to change. And yet somewhere at the very bottom of a South African gold mine life managed to turn that exact same condition, total isolation, into one of the most successful long-term survival strategies ever documented on this planet. Not despite the isolation, because of it. There might be a small, quiet kind of comfort in that if you are willing to let there be, there is a small detail buried in this story that I have been saving because I think it deserves its own moment. The name itself, De Sulphurudis or Dax Viata, is not just a random string of scientific Latin. The second half of that name comes directly from a 19th century adventure novel, Journey to the Centre of the Earth, written by the French author Jules Verne. Inside that story, a fictional explorer discovers an old inscription carved in Latin, a message urging any brave traveller willing to keep descending to eventually reach the very centre of the planet. When researchers needed a name for an organism found kilometres beneath the surface, quietly surviving in complete isolation, somebody on that research team clearly could not resist the reference. It is a small, almost playful detail hiding inside an otherwise deeply serious scientific discovery, and I have to say I love that a piece of 19th century fiction ended up permanently attached to something this real. It also raises a strange kind of question worth sitting with as we wind down this part of the story. This particular organism has apparently been down there for an extraordinarily long stretch of time, cut off from literally everything with no other species for company, no sunlight, no changing seasons, nothing at all beyond rock darkness and the slow, patient hum of radioactive decay keeping it alive. Is that closer to loneliness, or closer to a very strange kind of independence? I am honestly not sure there is a single correct answer to that question. Maybe it depends entirely on what you personally believe survival is actually for. What we do know is that this was not some strange one-time accident either. In the years since that first discovery, researchers studying similarly deep, similarly isolated water in completely different parts of the world, thousands of kilometers away in remote stretches of Siberia, and in mud volcanoes rising from the floor of distant seas, have found genetic traces of extremely close relatives to this same organism, quietly living the exact same kind of radiation-powered, sunlight-free existence. Different rock, different continent, different hemisphere entirely, and yet somehow life had independently arrived at almost the exact same unlikely solution more than once. Whatever this strategy for survival actually is, it appears to have worked out well enough that life has been quietly repeating the same trick independently, in isolated pockets scattered all across the deep dark corners of this planet, which brings us back to that gold mine in South Africa, the one we only briefly mentioned a few minutes ago because there is a great deal more to that particular place than the microbe living inside it. Mpumalanga is not simply the location where scientists happen to find something extraordinary. It is on its own one of the strangest and most extreme places human beings have ever chosen to work a location where the line between ambition and danger gets blurred in ways that have very little to do with biology at all, and where the daily reality on the surface for the people who actually work that mine might be even harder to believe than anything we've talked about so far tonight. That story. The story of the mine itself, the people who work there, and exactly how far humans have been willing to go chasing gold is exactly where we are headed next. Before we go any further, I want you to try picturing a single number for a moment. 4 kilometers. That is roughly how far beneath the surface of South Africa a person can actually stand right now on solid rock inside a tunnel built entirely by human hands. 4 kilometers down. For comparison, commercial airplanes cruise at around 10 or 11 kilometers above sea level. So somewhere in South Africa, there is a hole in the ground reaching down almost half that same distance in the opposite direction, purely so people could dig out a metal that, if we are being completely honest with each other, mostly just sits in vaults and jewellery boxes afterward. The mine is called Mponeng, and it currently holds the record for the deepest point any human being can physically walk to on this entire planet. A trip from the changing rooms at the surface down to the working face is not something you casually pop out for during a lunch break either. It involves multiple elevator rides, several changes of cage and stretches of walking through tunnels, lit only by headlamps, all before a single ounce of gold ever gets touched. To put that depth into something a little easier to picture, imagine stacking 10 replicas of the Empire State Building directly on top of each other, one after another all the way down. That towering stack would still fall short of how deep this mine actually reaches. The rock down there does not particularly appreciate the intrusion either. Temperatures at the working face regularly climb past 66 degrees Celsius, hot enough that unprotected skin would blister within minutes. To keep the tunnel survivable at all, the mining company pumps enormous quantities of ice, crushed into a slushy mixture, and sent down through pipes just to drag the ambient temperature back down to something a human body can tolerate for an entire shift. Something like 4,000 people descend into that heat every single day, riding a multi-level elevator car, often crammed, with well over 100 people at a time on a journey that can take upward of an hour before anyone even reaches the working level. At depths like these, the rock itself is under such immense pressure from the weight of everything above it that it can fracture violently and without warning, an event miners call a rock burst, essentially a small localized earthquake triggered by the act of removing stone from somewhere it was never meant to be empty. Engineers spend enormous effort trying to predict and manage that risk, but it remains one of the quiet, constant realities of working this deep inside the planet. A reminder that 4 kilometers of solid rock does not appreciate being hollowed out, no matter how carefully you go about it. Once they arrive, the gold itself is not exactly generous about revealing where it hides either. The specific seam workers are chasing at the very bottom of Mponeng measures somewhere around 75 centimeters wide, a narrow golden thread running through solid rock that miners must follow with drills and explosives inch by inch in heat that would leave most of us struggling to simply stand upright. Think about that the next time your own morning commute feels unbearable. Some people spend more time reaching their desk than most of Mponeng's workers spend simply reaching the rock they are paid to dig, and their entire working day still lies ahead of them once they get there. Now here is a question worth sitting with for a second. Why would anyone build something this extreme, this expensive, this plainly dangerous, chasing a metal that again mostly just gets locked away afterward? The answer, like almost everything else in this story so far, begins with an accident. A stroke of luck and one particular man who never fully understood what he had actually found. His name was George Harrison, and in the year 1886 he was working as a fairly ordinary prospector, the kind of wandering fortune seeker South Africa attracted by the dozens during that era. Not a wealthy man, not a trained geologist, just somebody who had already tried his luck in the goldfields of Australia and had come to southern Africa hoping for a second chance at the same kind of fortune. While exploring a modest farm called Langlagte, not far from where the city of Johannesburg now stands, Harrison stumbled across an outcrop of unusual-looking rock, a strange conglomerate studded with pebbles that caught the afternoon light in a way ordinary stone simply does not. He had spent time gold mining in Australia previously, and something about the texture of what he was looking at caught his attention. He was right to be curious. What he had actually found was the exposed edge of one of the largest gold deposits ever discovered anywhere on Earth, a reef that would eventually stretch for tens of kilometers beneath the surface, hiding wealth almost impossible to properly calculate, And then, in one of history's more painfully ironic footnotes, Harrison sold his claim for less than £10 and left the area entirely before the true scale of what he had stumbled upon became clear to anyone. £10. For a discovery that would go on to produce something in the range of a third of all the gold ever mined on the entire planet across recorded human history. Somewhere close to 1.5 billion ounces have come out of that single basin since Harrison's accidental discovery, an amount so large that economists still use it as a rough benchmark when discussing the modern gold market. Word of the discovery spread almost immediately, and within a matter of months, a tent camp of a few hundred fortune seekers had exploded into a proper town. Within a decade, that town Johannesburg had grown larger than Cape Town, a city that had already existed for over 2 centuries by that point. All of it traced back to one man, one lucky outcrop of rock, and one deeply regrettable decision to cash out early. Can you imagine learning years later exactly how much money walked away from you for the price of a modest dinner out today? I have to imagine there were nights that particular decision followed him. Meanwhile, the mine that eventually grew out of that same discovery is still operating right now this very evening under a different name and a different owner, one of the major mining companies that came to dominate the region long after Harrison himself had faded into a historical footnote. Somewhere beneath South Africa tonight, while you're listening to this, there is a real possibility that a shift of workers is riding that same elevator down into the same relentless heat, chasing the same narrow golden thread. Harrison first noticed glinting on the surface of an ordinary farm back when the whole story was still just beginning. The deposit Harrison stumbled onto that day is known as the Witwatersrand Basin, and geologists have spent well over a century trying to fully understand exactly how a single patch of ground ended up holding so much gold in the first place. One leading theory involves something we've not talked about yet in this story, an asteroid. Roughly 2 billion years ago, a massive space rock, likely several kilometers wide, slammed into the region, not far from where Harrison would eventually walk, carving out a crater so large that its outer rim, even today worn down by 2 billion years of erosion, still measures roughly 200 kilometers across, making it the largest confirmed impact crater on the surface of our entire planet. Some geologists believe that ancient impact helped churn up and expose the very gold-bearing layers that Harrison would later trip over quite literally more than 2 billion years afterward. Once again, this particular corner of the world seems to specialize in events that unfold across almost unimaginable stretches of time, quietly waiting long before any human being showed up to notice. None of that scale of wealth came without a human cost either, and I think it would be dishonest of me to gloss over that part of the story tonight. The tunnels beneath the Witwatersrand were dug largely by migrant labourers recruited from across southern Africa and housed in company-run compounds working brutally long shifts in extreme heat for wages that reflected almost none of the fortune being pulled out of the ground around them. Many of these men left home for months or years at a stretch, sending whatever small wages they could spare back to families who had no real way of knowing what conditions actually looked like at the bottom of these shafts. It is worth remembering whenever a story like this gets told with wonder in its voice, that the wonder sits directly on top of an enormous amount of very real human hardship. Gold has always had a strange talent for making that trade feel acceptable to the people who never had to make it themselves. That same tension between desperation and reward remarkably is still playing out at Poneng today, just in a very different form, because the official workforce is not the only group of people willing to risk everything for what sits inside that rock. For years, South African mining regions have dealt with what locals call ghost miners, sometimes referred to as zama-zamas, a term that roughly translates to those who try their luck. These are unauthorized miners who sneak into active or abandoned sections of deep mines, like Mponeng, sometimes staying underground for weeks or even months at a stretch, deliberately avoiding the surface entirely to escape detection, sleeping in makeshift shelters carved into old tunnels, working by candlelight and headlamp, in sections of the mine nobody is officially supervising. Down there, an entire hidden economy has been documented, forming around them smuggled food and supplies, sold at wildly inflated prices to people who have no other option but to pay it an ordinary loaf of bread reportedly changing hands underground for more than 10 times its normal cost on the surface. Cigarettes and batteries and simple comforts turned into small fortunes, purely because of how difficult they are to bring down safely. Spend that long entirely without natural sunlight and the human body starts to show it. Reports describe these ghost miners eventually developing a noticeably pale, almost ashen complexion, which is exactly where their nickname comes from in the first place. It is a deeply unsettling detail to sit with an entire population of people choosing prolonged voluntary darkness, risking collapsing tunnels, toxic air, and violent rival groups purely because the potential reward on the other side still feels worth that level of risk to them. I keep turning this comparison over in my mind and I am curious whether it lands the same way for you. In the very same rock at nearly the very same depth, human beings have spent well over a century risking their lives, their health, entire fortunes, and in some cases their freedom chasing a metal we mostly agreed collectively centuries ago should be considered valuable. And yet somewhere in that identical stretch of ancient stone, without a single person even looking for it, something else had been quietly surviving for millions of years, powered by nothing more than patient radioactive decay, needing absolutely nothing from anyone. One of those two treasures required armed guards, smuggled bread, and men willing to turn their skin pale rather than surface. The other one simply existed indifferent to gold prices, indifferent to greed, indifferent to every single decision Harrison, or anyone who followed him, ever made. Which one of those two discoveries do you think will still matter in another million years? I have my own answer to that, but I would rather you sit with the question a little longer than I let myself say it out loud. Gold, after all, only holds value because enough of us collectively agreed it should, an agreement that could theoretically change overnight. What was quietly surviving in that same rock never needed our agreement about anything at all. There is one more corner of this planet worth visiting before the night is through, a place that keeps its own kind of ancient secret, not inside solid rock this time, but underneath something colder, quieter, and in its own way even stranger still. A place where the darkness is not carved out by drills and explosives, but by roughly 4 kilometers of solid ice pressing down for millions of years on something that has been waiting just as patiently, just as completely alone for somebody curious enough to finally come looking. If you wanted to design the single most hostile place on the surface of this planet for a human being to actually live and work, you would struggle to improve much on the spot we're about to visit. It sits in the middle of the East Antarctic ice sheet, so far from anything resembling civilization that resupply flights only manage to land there a handful of times each year. The nearest permanently inhabited town sits well over 1,000 kilometers away, which means that anyone stationed there for the winter is for all practical purposes more isolated than an astronaut orbiting the planet in low orbit, who at least gets to see the lights of home passing beneath them every 90 minutes or so. The station built on that spot is called Vostok, and on the 21st of July 1983 the thermometer there recorded something that has never once been beaten anywhere else on the surface of the Earth before or since, minus 89.2 degrees Celsius. Cold enough that boiling water thrown into the air will freeze solid before it ever touches the ground. Cold enough that ordinary steel becomes brittle enough to shatter like glass on impact. Cold enough that simply breathing the outside air unprotected can injure your lungs within minutes. The small crew stationed there that winter had spent 10 straight days watching the temperature fall, degree by degree, with nothing to do but wait layered in specialized polar gear, breathing through pre-warmed tubes whenever a task forced them outside even briefly. And it was sitting directly above that same frozen wind-scoured patch of nothing that scientists eventually found one of the strangest hidden worlds on the entire planet. Back in the late 1950s, a Soviet geographer named Andrei Kapitsa began taking seismic readings across that same stretch of ice using sound waves to measure exactly how thick the frozen surface actually was in different locations. It was slow, painstaking work done largely on foot, and by sled decades before satellites made this kind of survey almost trivial. Buried deep in that data was something odd, a section where the readings behaved strangely, almost as if the ice at the very bottom was not resting on solid rock the way it should have been. Kapitsa suspected there might be liquid water hiding down there, but decades passed before anyone had the technology to properly confirm it. It finally happened in the 1990s once satellite instruments became sensitive enough to measure incredibly subtle variations in the surface of the ice sheet above that same spot. Water tends to sit unnaturally flat and smooth compared to ice resting on solid ground, and that telltale flatness eventually gave the secret away completely. In 1996, the scientific journal Nature formally announced what researchers had increasingly suspected for years. Buried beneath roughly 4 kilometers of solid ice, there was an enormous lake of liquid water, roughly the same size as Lake Ontario, over 800 meters deep in certain places, sitting in complete darkness, sealed away from the rest of the planet for what researchers now estimate could be somewhere between 15 and 20 million years. Can you picture that scale for a moment? An entire lake large enough to rival one of the actual Great Lakes back here in North America, hiding in total secrecy beneath one of the coldest, most desolate stretches of the entire planet, kept liquid this whole time, not by any warmth from the sun, which never reaches that deep, but by a slow trickle of heat rising up from the interior of the Earth itself, just barely enough to keep the water from freezing solid under the crushing weight of the ice pressing down on top of it. Somewhere close to 400 subglacial lakes have since been mapped scattered across Antarctica, but none of them come anywhere close to matching the sheer size of this particular one. Naturally, once scientists confirmed the lake was actually down there, the next obvious question became almost impossible to resist. How do you get to it? The Russian Antarctic program had actually already been drilling into that same stretch of ice since 1989 years before anyone confirmed the lake even existed, originally chasing something else entirely. That ice sheet, it turns out, holds one of the most valuable climate records on the entire planet. Tiny bubbles of ancient air trapped inside it, preserving a snapshot of Earth's atmosphere, reaching back more than 400,000 years through multiple complete ice ages. Climate scientists study those tiny trapped bubbles the way a detective studies fingerprints, reconstructing exactly how carbon dioxide levels, temperature, and atmospheric chemistry rose and fell across hundreds of thousands of years, long before anyone thought to wonder what might be waiting at the very bottom of all that ice. Once researchers realized their steady, patient drilling was heading directly toward an enormous hidden lake, the entire mission suddenly became something far bigger and far more delicate than anyone had originally planned for. By 1998, the drill had reached a depth of over 3.5 kilometers and stopped. Not because of any equipment failure, because of an uncomfortable question the entire international science community had to sit with together. If that lake really had been sealed off from the rest of the planet for millions of years, untouched, uncontaminated, essentially pristine? Was it even ethical to go crashing straight through it with an industrial drilling rig? What if the very act of reaching it destroyed the one thing that made it worth reaching in the first place? That pause lasted more than a decade, which I personally find to be one of the more admirable details buried inside this entire story. An enormous amount of institutional patience, national pride and scientific ambition, all quietly paused for years purely out of respect for something nobody had even properly seen yet. Eventually, on the 5th of February 2012, the Russian team finally broke through. And when they did, the moment turned out to be far more dramatic than a quiet, careful sip of ancient water. The pressure of the lake sitting beneath the enormous weight of nearly 4 kilometers of ice above it was so intense that the moment the drill finally punched through water, surged violently upward through the borehole like a geyser erupting in reverse, rocketing up through more than 3 kilometers of solid ice before the extreme cold refroze it, solid, locking a perfect natural sample of ancient lake water directly inside the borehole itself, almost as if the planet had decided to hand the sample over on its own terms. The team had to wait almost an entire year through the brutal Antarctic winter before conditions allowed them to safely return and actually retrieve that frozen plug of borehole ice for analysis. Here is where the story gets properly complicated though, and I think it deserves an honest telling rather than a tidy one. To keep that narrow borehole from collapsing shut, under the immense pressure of nearly 4 kilometers of ice, pressing in from every side, the Russian drilling team had been using a mixture of kerosene and a chemical called freon, roughly 60 tons of it, altogether sitting inside that borehole as a kind of industrial antifreeze. Scientists elsewhere in the world watching the mission unfold from a comfortable distance raised real concerns. A pristine lake untouched for millions of years was about to be breached through a column of jet fuel and refrigerant chemicals taller than most skyscrapers. One prominent glaciologist in the United Kingdom, watching the mission closely from his own research post, openly questioned whether anyone could really promise a clean sample when the drill had to pass through kilometers of that fluid to get there in the first place. The Russian team maintained that because these fluids were less dense than water, they would simply get pushed upward and away the moment lake water rushed in, never actually mixing with the lake itself. Other scientists were not entirely convinced that something this delicate could really be guaranteed with that much confidence, and the disagreement played out publicly in scientific journals and press conferences alike for years afterward. When the frozen sample finally reached laboratories back in St. Petersburg for analysis, the results turned out to be exactly as messy as those early concerns had predicted. Researchers reported traces of genetic material from thousands of different organisms scattered throughout the sample. For a moment it looked like Lake Vostok might rival Poning's own strange biology from earlier in the night. But the celebration did not last particularly long, because unlike the extraordinarily careful 4 times cross-checked methodology we talked about back at Kidd Creek, this particular sample simply could not be trusted with the same level of confidence. Was that genetic material really ancient life that had been quietly evolving in total isolation for millions of years? Or was some or even most of it simply contamination, hitching a ride on 60 tons of drilling fluid and years of complicated engineering? One of the Russian microbiologists working directly on the project put it about as plainly as any scientist possibly could. Even a single promising-looking organism from that sample might ultimately turn out to be nothing more than an accidental hitchhiker. I find something worth sitting with in that particular kind of uncertainty, if you allow me a moment to say so. Not every ancient secret gets to end with the same tidy, satisfying certainty we found earlier tonight, with these 4 independent noble gas clocks all agreeing perfectly with one another. sometimes even after decades of extraordinary effort, extreme cold national pride and real scientific care, the honest answer is still simply, we're not completely sure yet. That is an uncomfortable place for a story to land, admittedly. But it might also be a far more accurate reflection of how discovery actually tends to work out here in the real world, rather than in the version of science we usually see condensed into a single triumphant headline. Later expeditions using cleaner drilling methods with far less chemical fluid involved have since managed to collect additional samples with considerably more confidence, slowly narrowing the gap between what the Russian team hoped they had found in 2012 and what scientists can now actually stand behind with real certainty. There is something else worth mentioning here too, even briefly, because we'll come back to it properly later tonight. A lake sealed beneath thick ice, kept liquid by internal heat, rather than sunlight cut off completely from the world above it, sounds remarkably similar to something else entirely, something that does not exist here on Earth at all. Certain moons orbiting Jupiter and Saturn are believed to be hiding oceans of liquid water beneath their own frozen surfaces, in almost exactly this same arrangement, oceans that may hold far more water than every ocean on the surface of our own planet combined. Whatever engineering lessons scientists eventually learn from carefully respectfully accessing Lake Vostok may end up mattering far beyond Antarctica one day. Here is a question worth turning over in your own mind before we move on tonight. If you had spent an entire career chasing something that took decades to even reach, only to discover that the final answer was murkier and less certain than you had hoped for, would you consider that a failure, or would you consider it simply an unfinished chapter in a much longer story? I know which answer I lean toward, and I suspect the scientists who spent a decade patiently waiting out of pure respect for a lake they had not even seen yet would probably agree with me. Because as it turns out, water hiding beneath solid rock for 2 billion years and water hiding beneath solid ice for millions more were never actually the two most extreme examples of hidden water this planet has been quietly holding on to. There is a third one, and this next one is not tucked away in a mine or buried beneath a frozen continent. This one is sitting hundreds of kilometers beneath our feet, inside the solid body of the planet itself, in a place so extreme that scientists needed a diamond of all things just to prove it was really there. The diamond in question was not much to look at. 3 millimeters wide, an unimpressive muddy brown colour, the kind of stone any half-decent jeweller would glance at once and set aside without a second thought. And yet that small, forgettable little rock ended up rewriting what scientists understood about the inside of our entire planet. Here is how it actually happened. In the middle of 2014, while most of the planet had its attention fixed on Brazil for an entirely different reason, stadiums packed the World Cup, filling televisions in nearly every country on Earth. A small team of geologists quietly made their way instead toward the farmland surrounding a town called Uina, in a remote inland stretch of the country nobody was watching that particular month. While millions of people argued about penalty kicks and offside calls, this small group of scientists was crouched beside a muddy riverbank sorting through buckets of gravel, looking for something that would eventually turn out to matter a great deal more than any football match ever could. They were not there for football. They were there for diamonds, or more specifically for something hiding inside diamonds that almost nobody else in the world was thinking about. Local prospectors in that region have panned river gravel for diamonds for generations, and the researchers led by a geochemist named Graham Pearson purchased more than 1,000 of these stones directly from local miners. Not the sparkling, flawless kind jewelers dream about either. They specifically wanted the ugly ones dirty, cloudy, riddled with visible flecks and impurities, the exact stones a diamond dealer would reject outright. because those particular imperfections are not actually flaws at all. They are cargo. A diamond forms under such extraordinary heat and pressure so far beneath the surface of the Earth that whatever tiny fragments of surrounding mineral happen to be nearby, when the crystal forms often get trapped permanently inside it, sealed away in a capsule harder than almost anything else on the planet. When a volcanic eruption eventually carries that diamond up to the surface, sometimes over the course of mere hours, racing upward through the crust far faster than the mineral inside it would ever have time to change or react along the way, it brings its hidden cargo along for the ride completely undisturbed, preserved exactly as it was, however many hundreds of kilometers below ground it started out. Which means, in a strange sort of way, a diamond can act almost like a tiny indestructible delivery truck, hauling a sealed sample of the deep earth all the way up to a laboratory table without a single outside contaminant ever managing to get in. Pearson took several hundred of these unglamorous, commercially worthless diamonds back to his lab at the University of Alberta in Canada. He was not specifically hunting for anything to do with water. He was actually trying to find a reliable way to date these particular stones. And then, buried inside one single diamond no bigger than a grain of rice, his team noticed something they had never expected to see with their own eyes. A tiny inclusion of a mineral called ringwoodite. Now on its own that name probably means nothing to you, and that is completely fine because until that moment it barely meant much to anyone outside a fairly narrow corner of geophysics either. Ringwoodite is a specific high-pressure form of a much more common mineral called olivine, the same green-tinted mineral you might have seen in volcanic rock or certain jewellery. Under enormous pressure deep inside the Earth, somewhere between roughly 410 and 660 kilometers down in a layer, scientists call the mantle transition zone, olivine gets physically squeezed into this denser restructured form instead. Picture squeezing a lump of coal hard enough for long enough that its entire internal structure rearranges itself into something new, still built from the same basic ingredients but packed together in an entirely different shape. That is roughly what happens to olivine at those depths, and the moment that pressure drops, the way it inevitably would on the trip up to the surface ring, woodite typically reverts right back into ordinary olivine almost immediately, which means finding an intact piece of it still in its original high-pressure form, sitting on a laboratory table anywhere on the surface of this planet, should have been essentially impossible. Can you sit with that detail for a second, because I think it is quite possibly the most remarkable part of the entire discovery. This was the very first time in recorded scientific history that anyone had ever gotten their hands on a physical, tangible piece of that specific layer of our planet. Not a computer model, not an educated guess based on how earthquakes travel through rock. An actual sample sealed inside a diamond delivered intact from somewhere between 400 and 600 kilometers beneath our feet. And it was not just ringwoodite. When Pearson's team properly analysed the sample using spectroscopy and detailed crystal imaging, they discovered something folded into its structure that changed the entire conversation. Water. Not liquid sloshing water, obviously nothing you or I would recognise pouring from a tap. This water existed as hydroxide ions, individual oxygen and hydrogen atoms chemically bound directly into the crystal itself, making up somewhere around 1.5% of the mineral's total weight. 1.5% might not sound like an especially dramatic number on its own. Here is why it mattered so enormously. Geophysicists had spent nearly 50 years arguing over a truly fundamental question about our own planet. Is the mantle transition zone, that entire layer sitting between 410 and 660 kilometers down, wrapping around the whole of Earth like an invisible belt essentially bone dry, or is it soaking saturated with water locked away inside its mineral structure? For decades, that argument stayed almost entirely theoretical, built on second-hand evidence from how seismic waves travelled through deep rock during earthquakes, since nobody had ever actually held a direct physical sample from that depth in their hand. This one tiny unglamorous diamond finally settled it. If that single sample was even roughly representative of the transition zone as a whole, and there was good reason to believe it was, the implications were almost too large to properly picture. Scaled up across the entire volume of that layer circling the planet, that trace of water could theoretically add up to more total water than every single ocean sitting on the surface of Earth combined. Let that sit there for a moment, because I want to be careful about exactly what that does and does not mean. This is absolutely not some hidden underground cavern you could dive into with scuba gear, or shine a flashlight across and watch it ripple. That mental image, appealing as it might be, is simply not what any of this looks like. The water sitting inside that layer is chemically locked into solid rock, spread thin and invisible throughout an enormous volume of stone, the same way a fully soaked sponge does not have a pool of standing water sitting visibly on top of it, even though it might be absolutely saturated all the way through. Pearson himself was quick to clarify this point publicly more than once, precisely because so many people, hearing the headline, immediately pictured something closer to a lost world buried beneath our feet, some enormous hollow sea waiting patiently in the dark. The truth turned out to be considerably stranger than that particular fantasy, if you ask me. Not a hollow cavern at all, but something closer to an entire planetary layer of stone that happens to be quietly chemically damp on a scale large enough to rival every ocean we can actually see from space. There is also a small, slightly embarrassing footnote buried inside this story, one I find myself rather fond of. Pearson later admitted that other scientists may well have stumbled across natural ringwoodite before his own team did decades earlier, even without ever realizing what they were holding. The typical preparation process researchers use when studying diamonds, cutting, polishing, exposing samples briefly to heat during analysis, was very likely enough in earlier decades to cause any trapped ringwoodite to quietly convert back into ordinary olivine before anyone ever got a proper look at it. The evidence may have passed directly through other scientists' hands before completely unnoticed, destroyed by the very process meant to study it. It took a team specifically alert to that exact risk, handling the sample with unusually careful low-heat preparation to finally catch the mineral before it had a chance to quietly slip back into its more familiar, lower-pressure disguise. I keep coming back to that detail honestly because it says something almost humbling about discovery in general. Sometimes the proof you are looking for is not actually missing. It has already passed directly beneath somebody's nose more than once, simply dressed in the wrong disguise at the wrong moment. So where did all of that water actually come from in the first place? This is where the story connects to something enormous happening on a scale most of us never think about: the slow, grinding churn of plate tectonics. Over hundreds of millions of years, entire slabs of ocean floor thoroughly soaked with seawater at the surface get pulled downward into the earth at the edges of tectonic plates, a process geologists call subduction. You can actually watch a smaller version of this idea happen with something as ordinary as a wet sponge pressed slowly beneath the surface of a sink, full of water working its way deep into material that started out looking completely solid. As those slabs sink deeper and deeper, dragged down by their own weight, some of that water appears to travel with them, chemically bound into the minerals of the sinking rock itself, eventually settling into that transition zone hundreds of kilometers below. Some researchers have taken to describing the transition zone rather vividly, I think, as something close to a graveyard for old ocean floor, a place where pieces of ancient seabed have been quietly sinking and accumulating for an almost unimaginable stretch of geological time, which means the same restless grinding process that occasionally destroys an old seafloor on the surface may be exactly what built this enormous hidden reservoir far beneath our feet in the first place. Here is a question worth sitting with tonight if you are the kind of person who enjoys a healthy dose of existential vertigo before bed. Every single ocean you have ever seen a photograph of, every wave, every coastline, every drop of rain that has ever landed on your face might only represent a fraction of the total water this planet actually holds. What we call an ocean might just be the visible layer floating on top of something far larger, hiding in solid rock, patiently waiting hundreds of kilometers beneath the ground you are sitting on right now. Take a moment and try picturing every map of Earth you've ever seen, every one of those wide blue oceans stretched across the globe, and now imagine an equal or even greater volume of water, again completely invisible, tucked inside the planet itself, never once making it onto a single map anyone has ever drawn. Pearson himself, when asked why any of this actually mattered beyond simple curiosity, put it about as plainly as any scientist ever has. Water changes everything about the way a planet behaves. It softens rock enough to allow plate tectonics to function at all, it feeds volcanic activity, it shapes the entire churning restless engine running quietly underneath every mountain range and ocean trench on Earth. Without water woven into the deep structure of this planet in ways we're still only beginning to properly measure, Earth might not be the dynamic, endlessly shifting world capable of supporting life the way it actually is, which raises a much bigger question than a single diamond from Brazil was ever going to be able to answer on its own. If our own planet has been quietly hoarding this much water in places nobody ever expected to look, what else does it still remember buried in places we've not yet had the patience or the curiosity to properly search? That is exactly the question worth turning to next. Let's actually try answering that question properly, because I think it deserves more than a passing thought before we move on. Tonight, we have travelled to a mine in Canada, a gold mine in South Africa, a frozen lake buried beneath Antarctica, and a diamond pulled out of a Brazilian riverbank. 4 completely different places, 4 completely different stories, 4 sets of researchers who, as far as I know, never once sat in the same room together comparing notes. And yet laid out side by side like this, something bigger starts to come into focus, something none of these discoveries could have shown us entirely on its own. For most of the last century, if you had asked a geologist to draw you a picture of Earth's water, they would have sketched something fairly simple. Oceans on the surface, rivers running into them, rain falling from clouds, evaporating back up and repeating the cycle endlessly, all of it happening in a thin, visible layer wrapped around the outside of an otherwise dry, solid planet. That was the textbook picture for generations. It is also, we now know, almost embarrassingly incomplete. What tonight's stories actually add up to is something closer to Earth, having an entire second circulatory system, nobody properly mapped until surprisingly recently, water tucked into fractures 3 kilometers down, water sealed beneath ancient ice water, chemically woven into rock hundreds of kilometers beneath our feet. Not separate oddities, pieces of the exact same much larger puzzle. And once you start seeing it that way, an obvious question follows right behind it. Where did all of this water actually come from in the first place? You might assume scientists settled that question a long time ago. Comets write big dirty snowballs slamming into the young Earth billions of years ago, delivering ocean after ocean of ice that eventually melted. It is a wonderfully cinematic idea, and for a long time it was the leading theory almost everyone accepted without much argument. Here is the twist. when researchers actually measured the precise chemical signature of water inside several well-studied comets, ones with names like Halley-Hyakutake and Hale-Bopp comets. Most of us have at least heard mentioned somewhere comparing the ratio of an extra heavy form of hydrogen called deuterium against ordinary hydrogen. The numbers came back almost twice as high as what we find in our own oceans. Two bodies of water that share the exact same origin should carry roughly the same signature. These did not. Which means, as strange as it sounds, most of our actual ocean water almost certainly did not come from comets at all, despite that being the version most of us were probably taught somewhere along the way. The far better chemical match turned out to be asteroids instead, specifically a particular category called carbonaceous chondrites, water-rich rocky bodies from the asteroid belt whose deuterium signature lines up with our oceans remarkably closely. For a while that seemed to settle the debate. Water hitched a ride to Earth on asteroids rather than comets, end of story. Except, as you might already be sensing by this point tonight, the story never quite ends that cleanly. Because when researchers eventually got their hands on water sealed inside rock from deep within Earth's own mantle, the same general region we were just talking about with that diamond from Brazil, they found something that did not match either comets or asteroids particularly well. This deep mantle water carried a noticeably different, distinctly lighter hydrogen signature than the water sitting in our oceans right now. A signature that some researchers now believe traces back even further to the swirling cloud of gas and dust that our entire solar system originally formed from long before Earth itself had finished coming together as a planet at all. Which raises an almost unsettling possibility. What if some of Earth's water was never delivered by anything at all? What if it was simply here from the very beginning, baked directly into the raw material that formed this planet in the first place, billions of years before a single comet or asteroid ever needed to deliver anything extra on top of it? One research team even proposed a specific mechanism for how this could have happened. Early in Earth's formation, while the young planet was still little more than a ball of molten rock hydrogen from that same surrounding cloud of gas, may have dissolved directly into the churning ocean of magma covering the surface, then slowly sunk down toward the core as the planet settled and cooled, leaving a slightly different chemical fingerprint behind in the mantle compared to whatever arrived later on the surface through impacts. If that model holds up under further study, it would mean Earth's oceans and Earth's deep mantle water are not simply two versions of the same story. They may be two entirely separate chapters written at different points in this planet's very early history. Sit with that for a moment because I think it quietly reframes everything else we've talked about tonight. Every hidden reservoir we have visited, the fracture water in Canada, the deep biosphere in South Africa, even the transition zone humming away inside the mantle, may not simply be leftover puddles from some ancient bombardment. Some of it might be older than the bombardment itself, water that was never delivered to Earth, water that Earth was quite possibly born already containing the same way you were born already containing the blood type you would carry your entire life, rather than receiving it from somewhere else afterward. Can I offer you a slightly personal thought here? I find something oddly comforting about that idea. We tend to imagine our planet as this passive object sitting quietly in space, waiting for outside forces, asteroids, comets, sheer cosmic luck to hand it everything it needed to eventually support life. This newer picture suggests something a little different. That water, one of the most essential ingredients for everything that followed, might have simply been part of Earth's original recipe all along, not a lucky delivery but a birthright. There is something almost tender about that reframing if you let yourself sit with it. So much of how we tell Earth's story leans on external drama, catastrophic impacts, violent bombardment outside objects crashing in, to deliver exactly what was needed at exactly the right moment. It is a satisfying story, the kind Hollywood would happily option the rights to. But the quieter version, the one where Earth simply arrived already carrying what it needed, feels somehow closer to the truth of how most real lasting things actually come to be. Not rescued from outside, simply patiently already there waiting to be recognized. There is a second thread worth pulling on tonight too, one that connects directly back to the very first place we visited. Remember that water trapped at Kidd Creek sealed away somewhere between 1.5 and 2 billion years ago. Think carefully about exactly when that is, because the timing turns out to matter enormously. Somewhere in that same general window, roughly 2.4 to 2.1 billion years ago, Earth's entire atmosphere went through what scientists now call the Great Oxidation Event, one of the single most dramatic transformations in this planet's entire history. Before that point, Earth's atmosphere barely contained any oxygen at all. The air back then was dominated instead by carbon dioxide, methane, and water vapour, an atmosphere that would have been completely unbreathable to almost anything alive today, closer in chemistry to the toxic haze on a completely different planet than anything we would recognise as home. Then tiny photosynthetic organisms called cyanobacteria, quietly multiplying across the ancient oceans, began producing oxygen as a simple byproduct of capturing sunlight, the same basic chemistry every green plant still performs today. For an extraordinarily long stretch of time, that oxygen mostly got absorbed, immediately soaked up by iron and other minerals in the rock and ocean around it, like a sponge that had not yet reached its limit, rusting entire ocean basins full of dissolved iron into solid mineral deposits still visible in rock formations today. But eventually that sponge filled up. Oxygen began accumulating freely in the atmosphere for the first time in Earth's entire history, permanently transforming the chemistry of the entire planet, and according to some researchers, likely triggering one of the earliest mass extinctions in Earth's history among the older organisms that had never evolved to tolerate it, creatures for whom oxygen itself would have worked essentially as a slow, invisible poison. Which means that particular pocket of water sitting inside Kidd Creek was very possibly sealed away right around the exact moment this planet was rewriting the composition of its own sky. I find that detail almost dizzying, if I am being completely honest with you. Somewhere inside that ancient brine, chemically frozen the moment it became trapped, there may be a direct physical fingerprint of what Earth's oceans and atmosphere actually looked like during one of the most consequential transitions this planet has ever gone through. A transition most of us never learned about outside of a single paragraph in a school textbook, if we learned about it at all. Here is a question worth turning over in your mind before we continue tonight. How many other ordinary seeming details in your own life might actually be quietly connected to something enormous, if only you had the patience or the right instruments to trace the thread all the way back? Because that is essentially what all four of tonight's discoveries have in common. Water that looked on the surface like nothing more than an unusual curiosity turned out to be a direct physical witness to some of the largest events in this planet's entire history. Think about the sheer range we've covered tonight too, if you add it all up. A pocket of brine sealed in Canadian rock for 2 billion years, a single species of bacteria running an entire ecosystem by itself in South African darkness, a lake the size of one of the Great Lakes hidden beneath Antarctic ice for millions of years, a drop of water folded into a mineral crystal riding a diamond up from 400 kilometers below our feet. On paper, these sound like 4 unrelated curiosities you might stumble across in 4 completely different documentaries. Tonight, hopefully you're starting to see them instead as 4 separate witnesses, called to testify about the exact same, much larger case, the true, largely invisible story of water on this planet, We've spent tonight learning how to read water almost the way you might read an old letter, weathered, faded, written in a language most of us never bothered learning. Each discovery tonight has been another sentence pulled from that letter, another fragment of Earth's own autobiography written not in ink but in isotopes, mineral inclusions, and slowly accumulating gas. A geologist reading a sample of ancient water is not really so different from a historian carefully unfolding a brittle, centuries-old document, trying to reconstruct exactly what happened and when from whatever fragile evidence managed to survive. The only real difference is the timescale involved. Historians usually work in centuries. Tonight we have been working in billions of years, and the handwriting, so to speak, is written in chemistry rather than ink. There is something worth naming clearly before we move forward tonight. None of this fully answers the biggest question sitting underneath everything we have covered so far. We now have a far better sense of where Earth's water likely came from and how it has been quietly recorded across billions of years. But knowing where water has been hiding is not quite the same as knowing everything it might still be capable of, and that question becomes considerably more interesting once you stop limiting it to just one planet. Which brings us to a perfectly fair question, one I suspect at least a few of you have already been quietly wondering about tonight. If Earth has been hiding water like this in places nobody thought to look, what about other planets entirely? If water can survive sealed away in solid rock for 2 billion years, right, here kept safe from sunlight, kept safe from time itself, is there any real reason to assume the exact same thing could not be happening somewhere else in this solar system right now, waiting patiently in the dark for its own version of tonight's story to finally begin? That is precisely where we are headed next. There is no reason to assume it could not be happening somewhere else, and it turns out several very serious scientists at one of the most respected space agencies on the planet have quietly reached the exact same conclusion. In fact, one of them has already stood in the exact same tunnel we spent time in earlier tonight. A planetary scientist named Jesse Tarnas, working out of NASA's Jet Propulsion Laboratory, made his own trip down into Kidd Creek Mine, riding that same long elevator ride into the dark sampling, that same billion-year-old water working directly alongside Barbara Sherwood Lawler herself. Picture that for a second an actual NASA researcher, the kind of person who spends his career thinking about other planets for a living, standing in the exact same tunnel we described earlier tonight, headlamp cutting through the same darkness, breathing the same mineral-heavy air. He was not there out of simple curiosity about Earth's deep past either. He was there because he suspected that whatever was keeping something alive in that ancient Canadian brine might be the exact same recipe, capable of keeping something alive on an entirely different planet. Tarnas led a research project with a name that sounds almost like a piece of science fiction. Earth 4-dimensional subsurface science and exploration, built specifically around one central question. If life can survive this deep, this isolated, this completely cut off from sunlight, powered by nothing more than slow radioactive decay inside solid rock, could that exact same chemistry be happening right now, quietly underneath the red dust of Mars? To answer that, his team did something wonderfully specific. Rather than guessing, they went looking for actual pieces of the Martian crust, meteorites blasted off the surface of Mars by ancient impacts that eventually fell to Earth, and were recovered here, essentially free samples of another planet delivered directly to our doorstep. They analysed the chemistry of those Martian rocks, checking specifically for the same ingredients we talked about earlier tonight, sulfide minerals capable of converting into sulfate and radioactive elements, like uranium and thorium sitting there quietly decaying, generating hydrogen through radiolysis, exactly the same way they do inside Kidd Creek's fractures. What they found should give you a small chill in the best possible way. Those Martian meteorites had exactly the right chemical ingredients. If liquid groundwater exists anywhere beneath the Martian surface, and there is real evidence suggesting it might, certain instruments have already detected hints of subsurface lakes buried roughly a mile beneath the Martian South Pole radar signals, bouncing back in a way that closely resembles liquid water rather than solid ice. Then, according to Tarnas and his colleagues, there would very likely be enough chemical energy sitting right there to support exactly the kind of microbial life we found thriving in Kidd Creek and in that South African gold mine earlier tonight. The rover missions currently exploring the Martian surface, searching patiently for ancient fossilized evidence of life that may have existed billions of years ago, might quite possibly be looking in the wrong layer entirely. The far more interesting story, according to this research, could be happening quietly beneath their wheels, in groundwater none of those rovers are currently equipped to reach. Let that sink in for a moment. We're not talking about a hopeful guest dressed up as science. We're talking about a research team who deliberately treated a Canadian mine as a working laboratory model for an entirely different planet and found the comparison held up under real scrutiny. Does it not feel a little strange to realize that a mine you had probably never heard of before tonight has quietly become part of humanity's actual strategy for finding life beyond Earth? Here is a question worth sitting with. For decades, when people imagined searching for life on Mars, most of us probably pictured rovers scanning the dusty red surface cameras, searching for fossils, or scientists testing surface soil for the faintest trace of ancient microbes. Tonight's research suggests something quietly different. The most promising place to actually look might not be the visible, photographed, endlessly discussed surface at all. It might be directly beneath it in exactly the kind of dark, sealed, radiation-powered environment we already spent an entire part of tonight exploring right here on our own planet. Mars is not the only place this line of thinking leads either, and this is where the story gets considerably stranger. Roughly 628 million kilometers from where you're sitting right now, orbiting the giant planet Jupiter, there is a moon called Europa covered almost entirely in a shell of solid ice. Slightly smaller than our own moon, its surface crisscrossed with strange reddish-brown cracks that have puzzled scientists for decades. Europa does not look at first glance like a particularly promising place to search for anything alive. For decades, scientists suspected something might be hiding beneath that frozen surface, and in the 1990s a spacecraft named Galileo finally gave them real evidence. As Galileo passed close by Europa again and again, its instruments detected something odd happening to the powerful magnetic field surrounding Jupiter itself, a subtle distortion that, according to the physics involved, could really only be explained by one thing: a vast, salty, electrically conductive ocean sitting directly beneath that icy shell, extending all the way around the entire moon. An ocean hiding beneath the ice kept liquid despite the crushing cold of deep space, remarkably similar in principle to something we already spent considerable time with tonight sitting beneath the Antarctic ice sheet on our own planet. Except this one is not on Earth at all. This one is floating through space roughly 400 million kilometers further from the Sun than we are silently orbiting Jupiter once every 3.5 days. Right now, as you're listening to this, there is actually a spacecraft already on its way there. Europa Clipper launched in October of 2024, the largest interplanetary spacecraft NASA has ever built, and it is currently making its way through the solar system using gravitational assists from both Mars and eventually Earth itself to build up enough speed for the journey. It is expected to arrive in orbit around Jupiter in the year 2030 and begin its first close flybys of Europa the year after that. Which means somewhere out there tonight, humanity's best current attempt at answering this exact question is already quietly in flight, coasting silently through the dark between planets, while all of us go about our ordinary evenings completely unaware of it. And then there is Enceladus, a much smaller moon orbiting Saturn, barely wider than the length of the United Kingdom, which turned out to be even more forthcoming with its secrets than Europa has been so far. Enceladus does something Europa does not. It actively sprays material from its hidden ocean directly out into space. Enormous plumes of water vapor and ice erupting from cracks near its south pole, jetting hundreds of kilometers out into the darkness of space, visible enough that a spacecraft could simply fly straight through one and sample it directly, no drilling required. NASA's Cassini spacecraft did exactly that. In October of 2015, diving through one of these plumes at a distance of less than 50 kilometers above the moon's surface and sniffing its chemical composition with an onboard instrument. Scientists affectionately refer to as the spacecraft's nose. What Cassini found inside that plume when the results were finally published in the year 2017 connects directly back to something we already spent real time on earlier tonight. Hydrogen gas. Not from radiolysis this time, but from a different, equally compelling process. Warm ocean water reacting chemically with hot rock at the bottom of that hidden sea. Essentially the same basic chemistry, powering hydrothermal vents at the bottom of Earth's own oceans, environments already known to support entire ecosystems living in complete darkness. Scientists studying the data concluded that whatever is happening at the floor of that alien ocean is producing exactly the kind of chemical energy source that life, at least the kind of life we understand, would need to survive. One of the lead scientists on that study put it about as directly as a researcher usually allows themselves to saying that habitability, in the strict scientific sense astrobiologists actually use that word, appeared to already be present inside Enceladus, whether or not anything has ever taken advantage of it. To be clear, and I want to be properly careful about this part, nobody has found actual evidence of living organisms on Enceladus, or Europa, or anywhere else beyond Earth. Not yet. What has been found is something almost more interesting in its own quiet way. Proof that the basic ingredients and the basic chemistry required to support exactly the kind of life we found thriving in total darkness right here on our own planet already exist out there waiting. I keep coming back to something tonight, and I want to share it with you plainly. Every single discovery we have covered so far, the ancient brine in Canada, the lone bacterium surviving off radioactive decay in South Africa, the murky, uncertain sample from beneath Antarctic ice, all of it started out as a completely earth-bound curiosity. Nobody set out chasing that water because they were thinking about other planets. And yet, one by one, each of those discoveries has quietly become part of the very toolkit scientists are now using to imagine what might be waiting on worlds none of us have ever set foot on. Have you ever noticed how the most useful discoveries rarely announce their full purpose right away? Sherwood Lollar was not thinking about Mars when she first followed that smell through a tunnel in 1992. The team studying Memponeng's lone bacterium was not picturing Enceladus, sitting more than 1 billion kilometers away when they first sequenced that strange genetic sample. And yet here we are decades later, using exactly those unglamorous patient discoveries to help decide where humanity should point its next spacecraft and what instruments that spacecraft should carry when it finally gets there. There is something worth sitting with in that long after tonight's video ends. We rarely know in the moment which small, quiet piece of curiosity is going to end up mattering on a scale we could never have originally imagined. A geochemist chasing old water in a Canadian mine could not have known she was helping write the search plan for a mission to Jupiter. Sometimes the smallest, most overlooked corner of your own curiosity turns out to be exactly the piece the rest of the puzzle was quietly waiting on. For now, though, let's bring this story back down to earth quite literally, because there is one more kind of ancient water left to talk about tonight, and this one is not hiding kilometers beneath solid rock or drifting through space toward a distant moon. This one is sitting much closer to home than you might expect, underneath deserts, underneath farmland, underneath towns where people wake up every single morning and turn on a tap without a second thought. And the way we have been treating it quietly for generations says something rather uncomfortable about how well we actually understand the difference between something that seems endless and something that is quietly running out. Picture the Sahara Desert for a moment. Endless dunes, cracked earth, a landscape so dry it has become the universal shorthand for emptiness itself in almost every language on earth. Now picture that exact same stretch of land roughly 10,000 years ago, covered instead in grassland dotted with lakes home to hippos, elephants and crocodiles, wandering through a landscape that looked considerably closer to the plains of modern-day Kenya than anything resembling a desert. Archaeologists have even found ancient rock art carved into cliffs across the middle of the Sahara, showing herds of cattle swimmers and fishing scenes painted by people living in a version of this landscape that would be completely unrecognizable to anyone standing there today. That version of the Sahara was real. Scientists call it the African humid period, an extended stretch of wetter climate that gradually dried out as Earth's orbit and monsoon patterns slowly shifted over the course of several thousand years. And when all that ancient rain fell across that greener version of North Africa, a significant portion of it did not simply evaporate and disappear once the climate eventually changed. It sank downward into porous sandstone deep beneath the surface and stayed there sealed away by the same slow desertification that turned the surface above it into the driest place most of us can picture. That buried water is still down there right now underneath 4 different countries, in what is known as the Nubian Sandstone Aquifer System, the largest fossil water reserve currently known to exist anywhere on the planet. It holds something in the neighbourhood of 150,000 cubic kilometres of water, more than 500 years worth of the entire Nile River's annual flow, sitting quietly beneath Egypt, Libya, Sudan and Chad. Radiocarbon testing on that water consistently returns ages somewhere between 13,000 and 30,000 years old, occasionally older still chemical proof that it fell as rain during a version of this landscape that no living person has ever personally witnessed. Now here is where tonight's story takes an interesting turn, because unlike almost everything else we've talked about so far, this particular pocket of ancient water has not simply been sitting there quietly waiting to be discovered by a curious scientist decades from now. People have already started pumping it out on an enormous industrial scale right now in our own lifetime. Starting in the 1980s, the government of Libya began constructing what eventually became known as the Great Man-Made River, an almost unbelievably ambitious network of underground pipes designed to pull water from deep beneath the desert and pump it hundreds of kilometers north toward coastal cities and farmland. The scale of the engineering involved is difficult to properly picture. Thousands of kilometers of pipe, each section wide enough to drive a small car through, buried across empty desert, connecting hundreds of wells drilled deep into that ancient sandstone reservoir. At its peak, that pipeline system moved millions of cubic meters of ancient groundwater every single day, transforming stretches of previously unusable desert into productive farmland almost overnight. It was and still is one of the largest irrigation and water transport projects ever attempted anywhere on the planet, sometimes described only half-jokingly as the 8th wonder of the modern world. Here is the question worth sitting with, though. That water took somewhere between 13 and 30,000 years to accumulate. At the rate it has been extracted in recent decades, How long do you think it will take before the reserve runs critically low? I will let that question sit there uncomfortably for a moment, because the actual answer tends to catch most people off guard the first time they hear it. We're talking about timescales measured in generations, not millennia, for water that took millennia, not generations, to form in the first place. If you live somewhere far from North Africa, and this all still feels a little distant, I have another example much closer to home for a lot of you watching tonight. Beneath 8 entire American states, Nebraska, Kansas, Colorado, Oklahoma, New Mexico, Texas, South Dakota and Wyoming, sits an enormous body of underground water called the Ogallala Aquifer, sometimes referred to as the High Plains Aquifer. It formed a very long time ago, too, filled gradually by meltwater, pouring off retreating glaciers during the ice ages of the Pleistocene, a process some hydrologists estimate took as long as 6 million years to complete. For most of American agricultural history, that water sat quietly beneath the plains, largely untouched, because nobody had a practical way to reach it in any serious volume. Early settlers arriving on the high plains in the 1800s struggled badly with the region's dry climate until simple wind-powered pumps began appearing across the landscape, in the 1850s slowly making it possible to draw a modest, sustainable trickle of water up from below. That changed dramatically after the Second World War, when powerful new irrigation pumps and center pivot sprinkler systems suddenly made it possible to draw enormous quantities of water up from deep underground cheaply and quickly. Farmers transformed what had once been dry, marginal grassland into some of the most productive farmland on the entire planet, a stretch of country responsible today for something in the neighborhood of 1/5 of all agricultural output in the United States. Corn wheat cattle feed cotton, a huge share of it traces back in one way or another to that same underground reservoir. And here is the part of the story that should honestly give you pause. Today the Ogallala Aquifer is being drained at a rate roughly equivalent to 18 entire Colorado rivers every single year. In some parts of Texas and Kansas, the water table has already dropped by well over 200 feet since large-scale pumping began. In certain small pockets, the water is already completely gone. Meanwhile, natural recharge crawls along at a fraction of an inch of rainfall, actually making it back down into the aquifer each year, a trickle nowhere close to matching what gets pumped back out. Scientists studying the aquifer estimate that if it were left alone, starting today with no further pumping whatsoever, natural rainfall alone would take somewhere in the range of 6,000 years to refill it back to where it started. 6,000 years to undo what several generations of pumps have managed to accomplish in less than a single century. It is not entirely a story without hope either, and I think that is worth saying clearly. In parts of Kansas and Texas, farmers and local water districts have started adopting soil moisture sensors, more efficient irrigation systems and voluntary pumping limits, slowing the rate of decline in places that took the warning seriously early enough. It will not refill the aquifer, not on any timescale that matters to anyone alive today, but it at least buys time, stretching out what remains a little further into the future than it would have lasted otherwise. Small unglamorous decisions made quietly by people who mostly will never appear in a headline, doing what they can with the resource that took 6 million years to build and less than 100 to seriously deplete. I want to be fair here because I think it matters. Nobody involved in this story set out to be careless or destructive. Farmers in the 1950s reasonably believed at the time that groundwater simply refilled itself the way a rain barrel does after every storm. It is an intuitive, natural assumption to make, especially if you have never had a reason to think carefully about where your water is actually coming from, or how long ago it originally fell as rain. The mistake was not malice. It was a fundamentally reasonable-sounding assumption that simply happened to be wrong, applied at a scale large enough to eventually become a real crisis. Can I offer you an honest observation here, something that has been sitting with me the entire time I was researching this particular part of tonight's story? We have spent this entire evening marvelling at water that waited 2 billion years without a single complaint, patiently, silently asking nothing of anyone. And now in this very same story, we are looking at water that only had to wait 13,000 years, or 6 million numbers, that felt almost incomprehensibly vast every other time we mentioned them tonight, and watching human beings casually work through entire reservoirs of it within a single human lifetime. There is something worth sitting with in that contrast. The water at Kidd Creek survived every ice age, every mass extinction, every shifting continent completely undisturbed, purely because nothing on the surface ever had the ability to reach it. The water beneath the Sahara and the American plains survived just as long, quietly, patiently, right up until the exact moment we finally developed the technology to reach it ourselves. And once we could reach it, our patience for it lasted only as long as it took to notice it was profitable. Here is a question worth carrying with you past tonight long after this video ends. If a resource takes thousands or millions of years to form, and only decades to seriously deplete, at what point does calling it a resource at all stop being accurate and start becoming a kind of comfortable denial? We do not tend to think of water this way because water has always felt like the one truly renewable thing falling from the sky on a reliable schedule, filling rivers, refilling itself the way it always has. Some of it does behave exactly that way, but some of it, as it turns out, is closer to inheritance than income, a one-time gift from a much older version of this planet spent down a little further every single year. Maybe that is worth remembering the next time you turn on a tap without thinking about it, which, to be completely fair, is almost certainly most of the time for almost all of us, myself included. Somewhere beneath a surprising amount of ordinary, unremarkable ground in deserts and farmland alike sits water that predates entire civilizations waiting in the dark, exactly the way everything else we've discussed tonight has been waiting. The difference is this particular kind of ancient water is the one story tonight where the ending has not been written yet, and we happen to be the ones currently holding the pen. There is one final stop left on tonight's journey, and it does not involve a mine, a mission, or a measurement of any kind. It is simply a chance to sit with everything we have gathered tonight: the brine in Canada, the lone bacterium in South Africa, the uncertain lake beneath Antarctic ice, the diamond from Brazil, and now this water beneath our own farmland and deserts, and ask what all of it taken together is actually trying to tell us. Because I do not think tonight has really been about water at all, not entirely. I think it has been about something a little larger than that, something worth sitting with quietly before you finally drift off tonight. Let's go back for just a moment to where we actually started this whole journey. A narrow crack running through solid rock 3 kilometers beneath a quiet Canadian forest, and a single drop of liquid, thick and slow, sliding down stone that had not felt the touch of open air in longer than anything alive today has existed to measure. At the time, it probably just sounded like an unusual fact, a curiosity, something to file away and mention at a dinner party if the conversation ever happened to wander somewhere strange enough to need it. But look at everything that one small quiet detail actually turned out to be carrying. It was the beginning of a 20-year hunt carried by one woman who kept returning to the same unglamorous mine long after everyone around her had stopped asking why, all the way back to a nervous phone call to a lab in England, where someone on the other end assumed their own equipment must be broken. It was a mining town built on secrecy and stock market chaos back in 1963, decades before anyone thought to wonder what else that same rock might be quietly hiding underneath all that copper and zinc. It was 4 separate, completely unrelated radioactive elements, ticking away inside the exact same drop of water for 2 billion years, agreeing with each other so precisely that doubt eventually ran out of anywhere left to hide. It was proof that solid rock of exactly the right age and exactly the right stillness can hold on to a secret so completely that not even 2 billion years of ice ages, mass extinctions, and shifting continents could shake it loose. It was a single lonely species of bacteria thriving in absolute isolation nearly 3 kilometers beneath the South African gold mine, named after a line from a 19th century novel, powered by nothing but the quiet decay of radioactive stone close enough in spirit to something living at the bottom of a Canadian mine, that scientists now treat both of them as rehearsals for what we might eventually find on Mars or beneath the ice of a moon, orbiting Jupiter, or spraying out into space from the cracked surface of a much smaller moon orbiting Saturn. It was the coldest place ever measured on the surface of this entire planet, and a Russian team who waited a full decade out of pure respect before finally breaking through the ice into a lake nobody had ever properly seen. It was a diamond dug out of a Brazilian riverbank, in the same month the whole world was watching a football tournament instead, quietly proving that our own planet might be holding more water inside it than every ocean we can actually see combined water that may have been part of Earth's original recipe since the very beginning, long before a single comet or asteroid ever needed to deliver anything extra on top of it. And it was a reminder, uncomfortable in its own particular way, that not every kind of ancient water gets treated with the patience it deserves, that some of it is being spent right now faster than any of us tend to notice beneath deserts and farmland most of us will never think twice about. That is a remarkable amount of story to have been hiding inside one single, unremarkable drop of liquid seeping out of a crack in the dark. Here is what keeps circling back in my mind now that we've reached the end of it together. Almost nothing we talked about tonight looked impressive at first glance. A muddy-smelling crack in a tunnel wall, a 3mm diamond most jewelers would not have bothered picking up, a single species of bacteria invisible to the naked eye quietly running an entire ecosystem by itself in the dark. None of it announced itself, none of it arrived with fanfare. Every single discovery tonight had to be noticed by someone patient enough and curious enough to actually stop and pay attention to something the rest of the world had already walked straight past without a second glance. I think that might be the actual lesson sitting underneath all of it, if you are willing to let it be one. We live in a world that rewards loud things, quick things. Whatever shows up fastest, shines brightest, gets noticed first. Our phones are built around it. Our feeds are built around it. Most of us have quietly trained ourselves to scroll past anything that does not announce its value within the first 2 or 3 seconds of encountering it. And yet almost everything we spent tonight exploring together only revealed itself to people willing to do the exact opposite of that, to slow down to follow a strange smell down a dark tunnel, instead of walking past it to wait patiently for a decade out of simple respect for something they had not even properly seen yet, to keep coming back to the same unglamorous question for 20 years without a guarantee it would ever lead anywhere at all. None of those people knew in the moment that they were sitting on top of something enormous. That is worth repeating because I think it is easy to forget once a story like this one has already been wrapped up neatly and handed to you. Sherwood Lawler did not know in 1992 that she was starting a 2-decade journey toward one of the biggest hydrological discoveries of the century. The researchers studying that South African water sample were not expecting to find a single isolated species running its own entire ecosystem. Pearson was not hunting for water at all when he found it folded inside diamond. Patience in every single one of these stories was not a reward for already knowing the answer. It was simply the only available response to not knowing yet and choosing to stay curious anyway. Maybe there is something in your own life right now that feels a little like that. Slow, quiet, not obviously going anywhere yet. Easy to walk past, easy to give up on, easy to assume nothing important is actually happening underneath the surface of it. A skill you've been building for years without much to show for it. A relationship that is taking longer than you expected to feel solid. A version of yourself you are slowly, quietly becoming without anyone around you, fully noticing, yet maybe without you even fully noticing it yourself some days. I cannot promise you it will turn out the way Barbara Sherwood Loller's Patience eventually did. Nobody can truly promise that, and I would not trust anyone who tried to. But if tonight's story proves anything at all, it is that some of the most extraordinary things this planet has ever produced spent unimaginable stretches of time looking like absolutely nothing, sitting quietly in the dark waiting for someone willing to notice them. There is something almost tender about the idea that a 2-billion-year-old pocket of water and a quiet, uncertain stretch in someone's own ordinary life might actually be teaching the same lesson if you are willing to listen for it. Patience is not the absence of progress. Sometimes it is simply progress happening somewhere you have not learned to look yet. The rock at Kidd Creek was not doing nothing for 2 billion years. It was quietly keeping a promise nobody had even asked it to make, waiting for exactly the right person to finally come looking. I want to thank you properly for spending this time with me tonight, however long it has actually been for you, whether you're still wide awake taking all of this in, or already halfway into a comfortable, well-earned sleep by this point, which honestly would make me happier than almost anything else I could ask for. That is really the entire point of a night like this one, not to keep you gripped and wide-eyed until the very last second, but to give your mind somewhere calm and interesting to rest while everything else about your day finally quiets down. Stories like this one take a considerable amount of care to put together properly. Checking sources, following threads. Most people would never think to pull on trying to do justice to something this old and this easy to get wrong. There is a real temptation with stories this strange to round the edges off, to skip the uncomfortable parts, to make everything sound a little more certain than it actually is. I have tried hard not to do that tonight, even when the truthful answer was simply that scientists are still not completely sure. If any part of tonight made you feel that same quiet sense of wonder I felt while putting it together, that alone makes the whole thing worth it. If you are new here, welcome truly, and if you have made it this far into the video, would you consider doing one small thing for me before you finally close your eyes tonight? Hit that like button if any part of this story stayed with you. Subscribe if you would like more nights exactly like this one, and if you have a moment left in, you leave a comment down below. Tell me which part of tonight surprised you the most, the ancient water, the lonely bacterium, the diamond from Brazil, or that quiet aquifer running dry beneath farmland some of you are probably lying above right now. I read every single one of them, and they truly shape which stories I decide to dig into next. Because there is always another story waiting somewhere out there in the dark, patient, unassuming, sitting quietly, until somebody curious enough finally comes looking for it. That is the entire reason I keep doing this night after night, digging through old research papers and dusty historical records long after most reasonable people have gone to bed themselves. I already have the next one waiting for you, and I think it might end up surprising you just as much as tonight did, maybe more. I'm not going to tell you what it is yet. Some things are better left exactly where tonight's story started, sealed away in the dark for just a little while longer, waiting for the right moment to finally be found. Until then, get some rest if you can. Let your mind wander somewhere quiet, somewhere far beneath the ordinary noise of your day, the way we spent tonight wandering 3 kilometers underground, or 4 kilometers beneath Antarctic ice, or hundreds of kilometers into the solid body of the planet itself. And the next time you happen to notice something small and slow and easy to overlook, whether it is a strange smell in a hallway, a quiet idea you've been too busy to properly sit with, or simply a piece of your own life that feels like it is taking longer than it should, give it one extra moment of your attention before you walk past it. You never really know what it might be quietly waiting to become. Thank you again for spending tonight here with me. It means more than you probably realize. Sleep well, rest easy, and I will see you again very soon.